Hey everyone, I thought I had I do have the volume up. Oh my gosh, what's going on? I can hear myself. You can hear me. It's time for review. How's everyone doing? Brayden, great to see you here. Savannah, great to see you here. Alexa, good to see you here. Ford, Benjamin, Amy, how's everyone doing today? There we go. I swear the headphones don't sit in my ear properly. Leo, good to see you here. What's up, Leo? Leo knows the yo command on the YouTube. Good to see you here. Ella. Well, let's start off today's review session. I did put in all those timestamps, right? I'm not gonna delete those yet because I just want to make sure I didn't not put in those. Happy Sunday. Good to see you here. Juliana, good to see you here. Hey, everybody, let's throw out 1,000 points. You're here early. We're going to talk about how to review starting out here. So let's put a timestamp in here. How to review for the test. Let's just jump over to the main screen. Let's do this. So if you're here right now, you're reviewing. So that's a positive. You've already done it right here. Oh, no worries, Mikhail, right there. No worries. If you're here right now and there is a 320 review for the final right here, a 4-hour 320 review. So if you're looking for the 320 review, it's right here under the office hours. These are the videos that are open to everybody. There's a 320 review right there on the main page for Stats 1. You can see we're currently live right now with 23 viewers. Good to see you here, Ryan. So if you're looking for other ones, you can always click the Office Hours playlist right here, and this is everything we do live on the channel. Note that we have review part 1, and I do want to point out all the different things we did right here. You can go here to the more on it, and it's showing the timestamp still, and you can go here and see everything we're doing, all the different interpreting tests, just different things, the tools and techniques. We did a whole video on all these interpretations of tests and tools and techniques. The other video right here is a very good one too. On this one, we went over the whole formula sheet. We did everything formula sheet related. So we went and we talked about the formula sheet. I went in and put additional bookmarks, but we went to the formula sheet first off. So here we are with the formula sheet. And then we went in and solved problems with it. So we went and did confidence intervals and we went and did tests. So if you're looking for how to read the formula sheet, getting practice on what does everything mean on it, you'll see me go through, mark everything for the formula sheet, talk about it in the context. So we go through and talk about everything on the formula sheet right there. And then we do examples using it, whether do we do a confidence interval or whether we do a test. We go through and do an example problem using everything. Once again, here you see the 2 sample T where we go through and talk about everything on the 2 sample T formula sheet right there. And then we do a confidence interval with it. And then we do a test with it. So check out these videos. And we also talk a little bit about jump output, but that's a big suggestion. Another big place to go right here if you're reviewing for the final, other than the videos. Where can we access the formula sheet? Great question, Juliana. We're at 100 points right here. Mubot's about to drop a link in the chat. You're seeing it right there as the sound's a little bit too loud. So here is the link in the chat, and it's going to bring you right over to here, which is the Exam 3 review page. There it goes. It finally loaded up. And the Exam 3 review page has on it the formula sheet. So here's the formula sheet right here, which you can either print off or write down. Just make sure to show it. When you do your room scan, do it pretty slowly right there. Sometimes you might have to contact a student because they go, wee, and they just spin it around like it's on a turntable right there. So do a slow room check and be like, okay, there's my formula sheet. There's my room. Helps us out, and if you're not doing anything bad, then it's nice and easy. This is another great place to go with more review videos, whether you want to do test questions, which are the practice test questions found up here, or you want to go here to the speedrun videos with long hair Brian from the past, or you want to go down here, and these videos I think are some of the best. These videos are similar to the ones I did yesterday, where I go through here and I walk through kind of what is the notation of it. So you can see me writing down all the notation, writing a question, and then doing the 4 steps to hypothesis testing. So I go through, I explain everything, I go through the equations. These are great kind of focused videos where here we're live streaming so we get more interaction with people who are live. But these were not done live. This was just done where I went and explained the whole concepts, and that's got it. So that's how to review. Today we're going to do a little bit about like concepts because we've done a lot of different things. So we've got a little over an hour before we start doing some Kahoot. But what is a concept you're wondering about? I've got a few on my mind right now, like power, type 1, type 2 error, alpha, beta, confidence rules and tests. What concepts are you wondering about? Like today I wanted to do some concept stuff. So what concepts are you wondering about? Surely someone has a concept that they're like, I'm really wondering. Which side is that? It's on this side. I got it. Little piece of fuzz. What concepts are you wondering about? Surely there is a concept that you're like, we could say, all right, type 1 and 2 error. A lot of people wonder about that. Alpha and beta. We have power. What other concepts? Well, so we can do some interpretations, Savannah. We've got whole videos on those. Let me put interpretations on here. We'll start with type 1, type 2, and then we'll do interpretations. So we've done some interpretations. Power. Power is a good concept right there. Any other concepts? We've done, so we will do interpretations, Savannah, because you asked for it. Any other concepts? You name it. We're going to put them here on the list, and we're going to do as many as we can before Kahoot. Avery says power for sure. You bet, Avery. Give it another 10, 15 seconds here, see if anyone says anything else. We are on top chat. I know we're on live chat. I wish it would just default to live chat. Okay. Getting the word sheet open. Anything else? Any other concepts? You're like, I don't understand. What's up, Kristen? Good to see you here. So here we go. Concepts. Okay. We're going to start with some type 1, type 2, or we can do a little bit of interpretation after this. And Savannah, do you want interpretations of tests or intervals? We'll pick one of those. Tests or intervals? Are you interested in interpreting tests or intervals? Which one do you want? Is there a video on interpretation? No worries, Savannah. You asked, and it's an important part of the test that it goes to a lot of the concepts. How long will the Kahoot be? Probably about an hour-ish. And there's prizes. $30 for first place, $20 second place, $10 for third place. Tests, interpretations. Interpreting tests. Okay, so we've got some stuff to do, and let's start it. Here we go. Okay, so the first thing we're going to do right here is we're going to start by talking about type 1, type 2 error. Return of Epic Wolf, yeah. And with this right here, let's think of what are errors. What does it mean? Let's just say, what is an error? What is an error when we do a statistical test? Just we're talking about type 1, type 2 error, so we need to know the concept of an error. So what is an error? Who can help me out right here? So this is type 1 or 2 error. But the idea of an error is important right here. What is an error? That is a type of error. Incorrect, kind of not interpretation, but decision at the end, right? Incorrect decision. There's the fourth step of the test. If we look at any of our stuff from yesterday, when we did a test, we went down here, and at the end on the fourth step, we either rejected or failed to reject the null. So it's not that you do the wrong thing. It's that if you knew the truth, as though, great job right there, Ford. I think that's a great way to describe it too, Ford. We're going to make Ford a mod right here. If you knew reality, you would have made the wrong decision. Like, if we look at this test right here where we were testing UT students and we were testing the GPA of UT students, we rejected the null. This is this test right here. We rejected the null at the end. There was the p-value, and I think we changed the results we're talking about a different type of test. But in actuality, we rejected the null, but the null was what here? Like we said, I don't believe the null hypothesis anymore, but let's say we made an error. We're just saying, wait, did you make an error yesterday? We're just saying pretend. Like, if we made an error on rejecting the null, we shouldn't have rejected the null because the null was what? If we made an error on rejecting the null, we shouldn't have rejected the null because the null was what? We're just talking about what is an error right now. So we rejected the null, but the null was actually what? When you make an error, you reject the null, and I think Kristen was saying it earlier, but the null was true. So you shouldn't have rejected it. Now, you don't know that. You don't know when you make errors. Like, just theoretically, you can make an error when you're like, I reject the null. Well, you shouldn't have done that because the null was true. You're saying, well, then why did I do it? You didn't know that. You made an error. You might never know it. And we'll talk about these types of errors. Here's another one. Do we have the chi-squared on here from yesterday? Here it is. No, where's our chi-squared test? Did I delete that page? Oh, I knew that one had a not reject. So let's pull up the chi-squared or one of the chi-squareds because here we are. On this result right here, and how do you make your decision on rejecting or failing to reject the null? And this goes to a little bit of interpreting test results. What do you look at to determine to reject the null or fail to reject the null? What do you look at? Like, specifically, you have to look at this. You can assume the other quantity. You look at the p-value. And what is the p-value for this test right here? What is the p-value for this test? And we're just doing a bunch of questions, making sure we can read this output. What is the p-value for this test? So now put in the chat the p-value for this test. 0.1754. That's the chi-squared test statistic. So that's not the p-value, which no one put. Great work right there. And Lily, good to see you here. This is the p-value right here. And then when you look at the p-value, you simply ask yourself, is that above or below alpha? So let me ask you this. Is the p-value higher than alpha or lower than alpha? So if the p-value is lower than alpha, reject the null. If the p-value is high, just let it fly. It's higher. And alpha is assumed to be 0.05 unless otherwise stated. Alpha is just a bar. You're saying if the p-value is below this bar of 0.05, we will reject the null. The p-value is not below the bar. It's higher than it, so we are going to fail to reject the null here. But think about this. Failing to reject the null means we're saying we don't reject it. I fail to reject it. But in actuality, we've made an error, let's say. Like, we don't know this. You say, well, what do you mean you made an error? We don't know we made an error. It's just theoretically, the null could be what in this instance? If we fail to reject the null, we're going to memorize this here in a second. If we fail to reject the null, it could be an error because the null could be what? And this is the reverse of the one we just did. If we fail to reject the null, we could have made an error because the null might be what? The null might be false. And if the null is false, you should reject it. We're saying the null is a false statement. Well, then you should reject it. You can make an error by not rejecting it. So let's define these errors we just talked about. It's when we make the wrong decision on the test. Making the wrong decision on rejecting or failing to reject the null. We don't know we've done this. And I think the best way to talk about cheating, we all love talking about cheating. Haha, I hate it. Anyways, think about this. The null hypothesis is not cheating. The alternative hypothesis is cheating. Now, under the theory of why we put the alternative a certain way, why is the alternative hypothesis cheating? Because the alternative hypothesis requires what? To believe an alternative, you require what? So the probably good statistical theory to put cheating as the alternative hypothesis. The alternative hypothesis requires evidence. It's the evidence-based claim. The null, and great job there, Leo and Ford and Jessica, Alexa, it requires evidence. The null hypothesis is what we believe by default. It's like, I believe my students are not cheating, and then I need evidence to say they are cheating. So when you think about this, and this is how we memorize it, you ready? Someone already knows what we're about to do. We're going to go to the main screen to show this. I'm a little bigger. In a type 1 error, does everyone see the 1 right here? I'm going to keep saying in a type 1 error, the null is what? And you only talk about the null in these examples. The null is what? What am I making right here? In a type 1 error, the null is what? True. Now, if the null is true, it's going to be an error to what it? If the null is true, and Alexa's saying right there, it's going to be an error to reject it. If the null is true, you should just continue to believe it. We're saying the null hypothesis is true. Well, then that's what's true. Believe it. If the null is true, we should not reject it. In a type 2 error, so I'll hold it this way. In a type 2 error, the null is what? What letter am I making right here? In a type 2 error, the null is what? Think about the letter I'm making. False. That's an F. So if you see right here, there's an F. And we what it? Think of the second F right here. In a type 2 error, the null is false. And we fail to reject it. So think of the F's right there when we say false. Now I'll start to see here. False and fail to reject. Great job, Leo, right there. Already doing it before I can do it. Leo getting everyone some points. The null is false and we fail to reject. So there's the 2 F's of the type 2. I'd write that down on a sheet of paper and just practice. Say in a type 1 error, the null is true and we reject it. In a type 2 error, the null is false and we fail to reject it. So how does that apply here? Now be very careful and don't respond in the chat because we're going to see how many people get it. You ready? Let's go over and check this out. So don't respond in the chat. We're going to put a click button to see how many people get it. What is a type 1 error in this context? Okay. So let's put a student gets away with cheating, or a good student is accused. Which of these better describes a type 1 error? Now, don't put it in the chat. Let's see how many people get it. Now, here's the way to do it. When we talk about a type 1 error, you need to look at the null hypothesis and say the null is true. Now, we always slow our minds and we look at the null. I see it's about 50-50 right now, and this is why I slow it down. Which, here's the problem. It's a 50-50 guess, and that's why I'm like, oh, no. Oh, it's good. It's getting more towards one side now. But what are you going to do? And now it's almost 50-50 exactly. That's scary, everyone. Okay, wait, let's slow our minds. You ready? Just slow down. You ready? It's almost 50-50 in the vote. Look at the null and tell me it's true. Tell me what's true right now. Someone put what's true in the chat. Don't do the full thing right now. Just look at the null and tell me what's true. Look at the null. It is almost exactly 50-50. Look at the null and tell me what's true. You can write that in the chat. I know I said don't write in the chat, but now start writing things in the chat. Look at the null and tell me what's true. The student did not cheat. Does everyone understand when we say in a type 1 error, the null is true? Does that make sense right there to look at the null and say this right here is a fact about the world. When I say it's true, I'm telling you that's a fact. So don't even think statistics. Don't even use your stats knowledge. Just know that this is true. You did not cheat. So then using the knowledge of you did not cheat, what is going to be an error to do to someone who did not cheat? So just think of this. What is going to be an error to do to someone who did not cheat? So to someone who did not cheat, what's going to be an error here? What's going to be an error? You can write this in the chat. So the null is true to accuse them of cheating because it is true they did not cheat. But we think we have evidence. So what are we going to do to the null? Now remember, the null is true. But we as a teacher are going to do what to the null hypothesis here? We're going to do what to the null hypothesis? What are we going to do to the null hypothesis? Because we're going to accuse them of cheating. We're going to reject it. We're going to say, I got evidence against this. Now, the null is still true. You're saying, well, why are you rejecting it? Do you think a student has ever been accused of cheating who didn't cheat? Do you think that's ever happened? We say, someone's like, probably like, oh, it's me. I'm like, I'm sorry. So you are being accused, but you didn't do it. You did not cheat. But the teacher rejected the null and they think they have evidence to the alternative. So this is where someone has made an error. This happens all the time. People make the wrong decision when it comes to what they think they have evidence for. The teacher thinks they have enough evidence, but they've made the wrong choice. They were wrong to accuse you of cheating. The type 2 error. So let's talk about what a type 2 here is. And good work. Don't worry. We went a little bit over 60%. We're going to do another example of these. These are good memorization things, but always remember, whenever you do a type 1, just slow down and just look at the null and be like, that null hypothesis is true. That is what is the fact about the world. So in a type 2 error, the null is false, but we are going to what it. So that's a false statement about the world. If I said you did not cheat, I'm telling you a lie. So what is true, actually? I changed the question right there really quickly. But kind of a little, we don't say accept, we just don't reject it. We don't have evidence to go against it, so we don't really accept. We say, I can't reject that. Like, not that I'm saying it's true, I'm just saying, I don't have evidence. It's kind of sad. So you don't accept that your students are not cheating, Brian. In the statistical sense, I do not have evidence that they are cheating, so I can't reject the null hypothesis. I fail to reject it. So it's the statistical way, but no, I accept my students are not cheaters in the non-statistical sense. So in this, we are going to still believe it. I'll put a check mark right here because we're going to fail to reject it. We've been using that for the true, so let me not do that to not change colors. This is what is actually true. We don't talk about the alternative, but we are still going to stay with the null. Does that make sense? We're going to stay with the null. We're going to say, even though we don't know this, but even though the null is false, which means the null is a lie, we're going to fail to reject it. So this is when a student who did cheat, we believe they didn't cheat because we fail to reject the null hypothesis. Let's do another example right here. We talk about, whoops. Well, sure.
Tiny Brian.
Okay, there's Tiny Brian. He's going to talk about, well, we'll do it real quickly right here. He appears during class. And we have is not sick or is healthy and sick. Okay, so we're going to do a vote. Don't put the answer in the chat. What is a type 2 error? What is a type 2 error? So sick person told healthy. Healthy person told they are sick. A sick person told they are healthy. Okay, so let's see if we can do better on this. Now, in a type 2 error, do your thing. I'm not going to say it yet. I don't want to help out. It is like you're on the test right now. You have to figure out what is the type 2 error in this context. So the null hypothesis when you go to the doctor is that you're healthy. The alternative is that you're sick. And we're just practicing right here. We're trying to get the percentages up, just doing more examples. We'll see if we can we'll try to hit an 85%. We might have to do a third example. Let's see if we can get 85% of people on track with this. Because last time we were closer to almost 50-50, and that means it's a guess. So what is a type 2? Okay. How do you do it? And it looks like it's going towards one side, hopefully the right side. How do you do this? So now you can start answering in the chat. Now, how do you do this? Because that's 80% it looks like. How do you do this? So you look at the null and you say, in a type 2 error, that is what? In a type 2 error, you look at the null and what do you say? So what are you going to say? You can start answering in the chat for practice. This is a false statement. That you just look at it and you say, that's false. You just look at this and say, that is false. So tell me the truth about this person. So you look at it in a type 2 error, the null is false. So this is the truth about reality again. So now tell me about this person. So I think Kristen said it right there. The truth is they are sick because it is false that they are healthy. You look at the null and you say that is false. Like you somehow you know reality right now. You know the truth. So they are actually sick. You could go right here and mark a truth right here. We don't say that in our saying, but you can mark that the alternative is true. So they are actually sick. That is the truth of the world. Great job, Jennings, right there. That is the truth about the world, Nexus. Great work. So now they are actually sick. So think about this. It's going to be an error to tell them they are what? Which means you fail to reject the null. It's going to be an error to tell them they are what? They are actually sick. It's going to be an error to tell them they are healthy. Does that make sense? Does everyone follow along? We hit 70% on this question. So it was an error to tell them they are healthy. So let's do one more. We're at 68%. We got a little bit higher on that one. So let's do not win lottery. We're doing another one right here. Don't worry. We're practicing. We're trying to get the percentages up. Win lottery. Okay. So imagine this. You're trying to see if you should spend all your money because you want to know if you won the lottery. And you'd probably need evidence. Like, do you wake up most mornings and be like, I won the lottery? No, you'd probably need evidence. That sounds like the evidence-based claims right there, right? So let's think about a type 1 error in this context. You buy a Lambo when you shouldn't. So that would be thinking you won the lottery, but you didn't. Or you spend nothing but have millions. Spend nothing but are rich. Okay, so what is a type 1 error in this context? I'm kind of wording it differently. So the two options are you buy a Lambo when you shouldn't. So that would be like you go out and just start spending money willy-nilly. You're like, oh my gosh, I'm just going to buy everything because I'm so rich. And then the other option was you buy nothing because you think you have no money, but you actually are rich. So what would be a type 1 error in this context? So, okay, you ready? Slow it down. What's our way of doing this? Everyone repeat the statements. I want the full statement here. Let's write the full statement right now that we have to know. So we have to know this because we're still around the 70% mark. So stay the full statement. Joseph's doing it right there. Good work, Joseph. So in a type 1, give me the full statement. In a type 1, what about the type 1? In a type 1 error, the null is true. In a type 1 error, the null is true. So what is true right now? Just look at it and tell me what is true. What is true? In a type 1 error, The null is true. So what is the truth about the world? The truth about the world. Not accept, Joseph. Not accept. Because that's shows certainty. It is true you did not win the lottery. Does everyone understand that? You did not win the lottery. It is true you did not win the lottery. But you're going to what this now, as people are saying in the chat, you're going to reject it and say there's evidence you won the lottery because your friend called you up and said, hey, dude, you won the lottery. So you go out and buy a Lambo, and you shouldn't have. The null is true. I really want us to hit this 80%. We keep getting 2/3. And remember, this is a 50-50 thing. Do this for the next one. I'm going to walk you through it, and I'm going to tell you the steps. And no one answer until maybe I won't put the things in here. Okay, we're going to do one more because I'd like us to hit 80%. I'd like you to see that. Do it this way. Write it down and circle them. Exactly. You think you have money when you don't. You're like, my friend called me up. He said I won the lottery. That's my evidence. I rejected the null. I went out and bought that Lambo. And so you didn't win. They were messing with you. April Fools. Haha. You're in debt now. Haha. Not funny. Okay. So let's do one more, but I'm not even going to put the things in. So don't answer this in the chat because we're going to see if people are. So, no, thank you so much. Like, it helps me know how much more I need to review. So we're going to do one more right here. And we're going to see if how people are doing it. But I'm going to do the steps, and then I want you to answer it, like with the survey question. You ready? So let's think of, I'm thinking of more examples because I don't usually have this many. I know one. No, it's the same as sick. It's the one I use in the Kahoot. Give me a second. I'm trying to think of another example. Like, would be a good null, because this is like theory for it. You think, okay, friend will pick you up, and you need evidence your friend won't pick you up. Okay. The null hypothesis is that your friend's going to pick you up from the bar. Like, you just believe. Your friend usually picks you up, so you just believe by default that your friend's going to pick you up. You believe by default. Like, if I said, do you think friends can pick you up? You're like, yeah, my friend usually picks me up. That's my null hypothesis. My friend's going to pick me up. They usually pick me up. So that's my null. I don't need evidence. I need evidence, rather, that they are going to not pick me up from the bar. Okay, so don't answer this because we want to see if people are getting it. What is a type 1 error? So remember how we do this. I'm going to do the steps here, and then I'm going to put the question in the chat. So let me put this right here. What is a type 1 error? I'm not going to hit submit on this yet. Waiting for your... Don't answer, though. Okay, here we go. In a type 1 error, the null is true, but we reject it. But the null is a true statement. That is true. Your friend will pick you up. Your friend will pick you up. So it is true that your friend will pick you up. The question's in the chat now that should appear. It is true that your friend will pick you up, but you rejected that. It is true that your friend will pick you up, but you rejected that. There's a type 1 error. It is true that your friend will pick you up. That is a true statement about the world. Your friend will pick you up. It is a true statement about the world that your friend will pick you up. It is a true statement about the world. And we're finally hitting that 80-85% barrier that I was hoping for. It is a true statement that your friend will pick you up. That is true. But you rejected that. You said, I don't believe that. So what did you do? Since you rejected that your friend will pick you up, as the question states, since you rejected that your friend will pick you up, you said, I rejected that. It's true that my friend was going to pick me up, but I rejected that. And I want you to think about this. Would you ever find out that you made the error? Would you ever find out what's going to happen as you're walking home? We're at 84% on it. What's going to happen as you're walking home? You're probably going to get a call on your phone. Your friend's going to be like, dude, I'm at the bar. Where are you? And you're like, I was walking home. I rejected the null hypothesis. And they're like, stop studying for statistics. Chill out, man. So with this right here, you might find out you made the error. Your friend calls and they're like, hey, I'm at the bar. Where are you at? And you're like, I rejected the null hypothesis. And they said, no, it's true that I was going to pick you up. You shouldn't have rejected that. You made a type 1 error. The null was true. I was going to pick you up. You rejected it and decided to walk home because you thought there was evidence, because maybe you heard from your friends that they were out of town. Like you had evidence like they were out of town, that they were not going to pick you up. So you're like, well, I guess I got to walk home. And so you made the wrong choice when you decided what to do with your null hypothesis. Who feels like, does anyone feel like, I'm hoping we've reached a higher percentage? Please, I highly suggest doing it via this methodology right here, where you write it and you circle it and you look at it and you say, this is true. My friend will pick me up. You just look at that and say, that is a true statement about the world. My friend will pick me up, but I'm rejecting that. And I'm going to make the wrong choice here. I'm going to think my friend won't pick me up. So hopefully this helps out in the ways to do type 1, type 2 error, where type 1, the null is true and we accidentally reject it. And a type 2, the null is false and we fail to reject it. And the other ones right there in the chat are the type 2 false, where you wait for your friend and they don't pick you up, because in a type 2, the null is false. Your friend's not going to pick you up, but you fail to reject that and you hang out thinking they will. Okay, well, I'm hoping, did that help everybody really nail down type 1, type 2? That's kind of my goal right here today with these questions, to help you out right there. I'm hoping it did, so fingers crossed. That's type 1, type 2 error. We'll do power now, then we'll probably do some interpretations. Let's over to the main screen and do some power. Okay, and remember, ask all those questions. So we're going to do power now. How's everyone doing? Zachary, Caitlin, good to see you here. We got 28 votes, 28 people watching live and interacting. We're going to do, how is the hamster? The hamster? We have bunnies. The hamster. Hamster. Do we have a hamster? If we have a hamster, I don't know about it. Bunny. No worries for it. Always confused. Should you? Chelsea, do we have hamsters? She didn't reply. That's a no. We've seen the bunnies. We'll do a quick interlude right here while I get everything ready. Here is a bunny interlude. There's our bunny interlude. There, Jolly doesn't mind being picked up so much. That's Morty right there, and he's 50-50 on if he likes to be picked up. Jolly's not the biggest on being picked up. Morty. Jolly's pretty cool with it. He's all right. Yeah, maybe one of these days. Just Jason living? No, Jason's in. Yeah, he's in Knoxville. Yeah, he's not in College Station. And so let's talk about power right here. Yeah, he's around Haslam College of Business. If you ever seen him, be like, hey, Jason, he'll be like, how do I know? You'd be like, Stat 201. He'll be like, Brian does all, he did quite a bit of our intros. He did the Stranger Things intro, which everybody loves. One of the top intros. Power. What is power? I would highly suggest with power having a definition to start. What is a definition of power? Who knows the definition of power? So let's go for textbook definition to start. I'd put this on a note card. Textbook definition of power. Like literally, if you look in a textbook, statistical textbook, if you Google it, you'll probably see this. What is power? Just see if you know it. If you don't know it, have a note card. Go grab one right now and put it on a note card so you just know the textbook definition. That's all right, Kristen. That means we need to practice. Let's write it down right here. The ability to correctly reject the false null hypothesis. So if you look at the correctly rejecting the false null hypothesis, which if you correctly rejected Alexa right there, then the null was false. Does that make sense? Is the probability of rejecting the null hypothesis when in fact it is false? Did you Google it? And it is a probability. It's calculated based on probabilities. So so you could say the probability. A lot of times say the ability or the probability we correctly reject the false null hypothesis. Yeah, it's based on a probability and you do power calculations. So right here, the ability, if you look at the main key components, it's correctly rejecting the false null hypothesis. So it's when the null is false and we're able to reject it. So if you think about a powerful test right here, this was at the end of chapter 16. We're going to talk about the things. Yeah, it's at the very end of class, like a 15-20-minute segment. That's why, hence, I'm doing these today right here, because I want to make sure people remember some of the concept stuff, because we haven't done these lately, so it's a good time to review. Think about this. How do doctors test for sickness or test for health? I mean, I guess you could say both. But generally, if you go to the doctor, they're going to test you for what? Like, what do they look for evidence for when you go to the doctor? So what do they look for evidence of? Sickness, right? So they're going to assume you're healthy, and they're going to look for evidence of a sickness. So they're going to look for evidence of sickness, right? This is the evidence-based claim. They're going to assume you're healthy until they have evidence of sickness. You could reverse it, though, I guess. If someone is currently sick, they could say, is there evidence you're healthy? But for in most cases, most doctors, they're going to assume you're healthy when you walk in the door. Then they're going to look to see if there's evidence of a certain sickness. So when we think about correctly rejecting the false null hypothesis, well, if the null is false, then a person's actually what? If the null is false, then a person is actually what? If a null is false, then a person is actually what? If the null is false here, they're actually sick. So I want you to think, in the words of a doctor, a powerful test would help you determine if people are what? A very powerful test would be able to find people who are this. Remember, the null is false, we're saying. It correctly rejects the false null. A powerful test can figure out if people are what? Like I have a really powerful test. It can figure out if people are sick. Does that make sense? This is like a really good, really powerful test. And so which of these tests probably sounds more powerful to you? Let's just think about this. The doctor takes 1 drop of blood. The doctor takes 5 vials of blood. Dr. Acula takes 5 vials of blood. They spell vials? I don't know. Dr. Mike takes 1 drop of blood. Dr. Acula takes 50 vials of blood. There we go. 50 vials. How do you spell vials? What is vials? Is it not a word? It's not a word. There it is. There we go. So who's doing a more powerful test right here? Dr. Mike? It's violent. It apparently is. Who's doing a more powerful test right here? Just think about this. Who would be better able to detect that you're sick? Now, might be some consequences to the powerful of the test. Millie gets it right there. Dr. Acula is definitely doing a more powerful test than Dr. Mike right there. I mean, Dr. Mike might have more training, though. You know, I think he's a DO. So, but with this right here, we're actually covering one of the concepts of power. Remember, power is the ability to correctly reject the false null. How did Dr. Acula do a more powerful test? Assuming you're still alive after this, here we'll go back to 5 vials. He's got to be careful, got to keep you alive. I mean, gotta. So, why is he doing a more powerful test conceptually? That is true. He took more blood, so he can examine it more. Right? He can like get a better understanding of what's going on. Right? He can do a lot more with that. Right? What did he increase right here? What did he increase? So Dr. Acula, one of the 3 concepts, and Leo said it right there, he took a larger sample. This is a larger sample. Does that make sense? He increased the sample size right there. If you increase your sample size, what happens to power? If you increase your sample size, what happens to power? Power goes up. Does that make sense? Power goes up. Another example right here. Let's say this right here. So we're going to do the next concept. Here's the next concept when it comes to power. We got Dr. Mike versus Dr. Acula. And the other concept is going to be Dr. Mike only works with people with colds. Works with colds. Dr. Acula works with, let's say, people. I'm trying to think like brought in on stretchers. Dr. Acula patients brought in on stretchers. Okay. So what is the difference here between Dr. Mike and Dr. Acula? We're reviewing the concepts, so if you watch these examples right here, I'm going to tell you what the concept is that we're increasing and changing between these. Where Dr. Mike works with people who have the common cold, and Dr. Acula is just in the ER right here with people on stretchers. So what is the difference right here? Now, we're taking the same amount of blood in this instance. We're going to talk about these concepts, but these are the three things that impact power, what we're going over here in these examples. So the first one was Dr. Acula is taking a larger sample size, increases power of the test he's doing. Where Dr. Mike in example 2 right here is working with people who have the common cold, where Dr. Acula is working with people who are passed out on a stretcher when they're brought in. They're like, this person passed out and we need to figure out what's wrong with them. So what is the concept here we're covering? What has increased for Dr. Acula, whose tests are going to be more powerful? And this one's an interesting one. This one's a conceptual one. Does anyone know? I'll answer in like 10 seconds right here. He only sees patients at nights. That is correct. Here, I'll abbreviate this one. What is increased is this. The increase right here is the effect size. The effect size is a harder concept to understand. It's more difficult than taking a larger sample. The effect size is the distance between the null and the truth. So the null hypothesis is that someone is healthy, right? Does everyone get this right here? That the null hypothesis is that someone is healthy. Where Dr. Mike, we'll put right here, is seeing people with the common cold. And so here is like how much a cold has from being healthy. Where Dr. Acula, we'll use a different color. Cool. Dr. Acula's patients are way further away. When would you be more likely, when would you be more likely to realize someone is sick? If they're passed out or they have a cold. Like if you walk in and your friend's like, and you're like, are you sick? And they're like, I don't know, maybe. Or if your friend's like passed out, when would you be more likely to be like, there's a problem here, like this person is sick? Which one of those is further away from the null hypothesis, which that's what effect size is. Effect size is the distance, and let's write this here as a definition. Effect size is the distance from the null and the truth. So if it's true that all of Dr. Acula's patients are passed, like have some sort of thing that they're passed out, like they're passed out from sickness. So let's say from sickness. So they are sick and they're passed out from the sickness. They've totally passed out from the sickness. Where all of Dr. Mike's patients actually have colds. The effect size for Dr. Mike's patients is a lot smaller and harder to detect. Dr. Mike might be more likely to tell his patients they're what? Like Dr. Mike might be more likely to tell his patients they're what? Think of this. Dr. Mike is going to be more likely to tell his patients they are what? They're healthy. Does that make sense? Exactly right there, Leo. He's going to be more likely to say, you're healthy. Like, you got the sniffles. Where Dr. Acula is keeping him there for a long time, being like, no, I reject the null hypothesis. Dr. Mike is more likely to make what? Remember, Dr. Mike has, every patient Dr. Mike has, we're saying, has a cold. They are actually sick. Dr. Mike is more likely to make type 1 or type 2 errors. Let's take a vote in the chat. Dr. Mike would be more likely to make type 1 or type 2 errors. What is Dr. Mike more likely to make? So think of what a type 1 or type 2 error is. This is a review of the previous thing we just did. Dr. Mike would be more likely to make what errors? And remember, so we think about this right here. Dr. Mike is more likely to tell his patients they're healthy when they are not. So if you tell a patient that they're healthy when they are not, you've made a what error? So when I said they're not healthy, what should you do to the null hypothesis? Let's see what he'll say. Dr. Mike is probably going to fail to reject this a lot, right? So what error? Someone put it in the chat. Dr. Mike's probably going to fail to reject this a lot. And because of that, Dr. Mike is probably going to make a lot of what? Sorry, Dr. Mike. Different Dr. Mike in this example. He's probably going to make a lot of whats. Because he's going to be like, oh, you're healthy. Because there's not a big effect right here. It's hard to detect. It's got the hard job. He's probably making a lot of type 2 errors because the null is false. Every one of his patients has a cold apparently, but the null is false. Dr. Acula over here is seeing people who are like passed out, so he's going to be more likely, he has a more powerful test, less likely to make a type 2 error. Who knows the last thing? The last thing that controls type 1-2 error. The last thing that controls type 1 and type 2 error is going to be, we might have to delete that. The last thing that controls type 1 and type 2 error is going to be what? These are the three things you need to know that control type 1 and type 2 error. Kind of beta, yes and no, but, and we'll talk about that here in a second. Kind of beta, but not. Alpha. Dr. Mike uses 0.05 alpha. Dr. Acula uses 1.00 alpha. So I want you to think about this. Alpha is just when we reject the null hypothesis, right? So what percent of the time will Dr. Mike make a type 1 error? Alpha tells us that answer. Alpha is your type 1 error. So I think you're getting at the next thing. Dr. Acula has a more powerful test. Dr. Acula will make a type 1 error what percent of the time, or is allowing for this what percent of the time? Dr. Acula has a type 1 error rate of what? So tell me any of their type 1 error rates. Alpha literally is type 1 error. The type 1 error you're allowing for is alpha. 100%, right? Dr. Acula is going to tell everyone they're what? He's rejecting the null for everybody, right? So Dr. Acula is saying, I reject the null hypothesis here. You're sick. For everybody. He's a bad doctor. So Dr. Mike's using the correct sign, the alpha we use most commonly, 0.05, everyone's sick. So will Dr. Acula find everyone who's sick? Will Dr. Acula find all the sick people? He will, right? But he's also going to tell a lot of healthy people that they're sick when they're not. So if you increase your type 1 errors, you'll do what to your type 2 errors? If you increase your type 1 errors, you will do what to your type 2 errors? Increasing type 1 errors by just telling everyone you're sick, you're sick, you're sick, you're sick, you're sick, which Dr. Acula is doing by using a 1.0 alpha, which we'd never do. And Kristen did a great job right there. We are going to decrease our type 2 error, which is known as beta. Now, here's the thing. All of these decrease beta. When there's a higher effect size, there'll be a lower beta. When there's a higher sample size, there'll be a lower beta. So every concept we just talked about is the inverse of beta, like larger sample size, lower beta. Higher effect size, lower beta. Higher alpha, lower beta. Because the equation for power, and this is where it all comes together, when you think about what is power mathematically, power is equal to what? So it's a good step right here. Do you know what power is? Power mathematically, think about this. If all of these decrease beta, power mathematically is calculated by 1 minus beta. So think about this. If beta gets smaller, just look at this down here. If beta gets smaller, power gets water. which it's a probability. The probability gets water. If beta gets smaller, which all those do is beta getting smaller, then power, which is 1 minus beta, power gets larger. So power is just 1 minus beta. So if you're decreasing beta, well, then you're increasing power. So just conceptually right here, by taking a larger sample size, you decrease beta, which increases power. If you increase effect size you don't really control effect size, but if there is a larger effect size, you would decrease beta, increase power. If you use a higher alpha, then you decrease beta, increase power. Which of these do we have the most control over? Which of these concepts, sample size, effect size, or alpha, do we have the absolute most control over as a researcher? Which of these do we have the absolute most control over? You could argue 2 of these. The 2 that we have the absolute most control over are what? The 2 concepts on the screen. We can completely, Lily, great job. I'm going to make Lily a mod right here. We have control over alpha. Now, Mike is using the right stuff right here. He knows how to do good statistics. 0.05 alpha is what we use by default, but we completely can control it. You can change, you just say, I want to use this alpha level. You just pick it. Some people use a lower level of alpha, and that's probably pretty good to do. Now, you'd probably need to go back to the drawing boards and redo how you did the test, but you also control this, but you don't really control effect size. Effect size is the distance between the null and the truth. You don't control how sick someone is. It's going to be harder to detect people who are a tiny bit sick. Great job right there, Avery and Alexis. So the 2 we really have control over, you can change your alpha level at any time. It's not advised to not use 0.05 alpha. It's just what was decided on by Ronald Fisher, I believe, to just be like 0.05 alpha. And so we kind of keep to that to be consistent. And then your sample size is like your starting. So basically, Acula he'd have 100% power. He would detect everyone who is sick. Yep, Braden right there. He's saying everybody's sick. You just walk in the door and he's like, "Welcome here. You are sick." And you're like, "He didn't even run a test." He's like, "I just say everybody's sick." You say, "Okay, I'm sick," and he'll find all the sick people. Then, right? He'll correctly reject the null all the time. He'll make no type 2 errors. Exactly. His type 2 error rate is 0. Another thing to know. How do you find your beta? Hayden, great question right there. There's what's called power curve calculations. So let me show that, but we won't be doing that. So power curve calculator online. We will not I don't know what side I'm on, except cookies, no. Power and sample size stats kingdom. Oh, sorry, this URL has moved. So I think this is a safe site to show. We will not be doing this in our class. Our class does not do this. This is something especially Russ and Brandon. The power right here, this is power curves and how they're calculated with the null. You notice right here. Here's the truth over there saying the alternative is true. So they're doing the power calculation, the ability to correctly reject the null hypothesis. And this is going to be, I believe, the power right here. Let me make sure I got the right side of the power curve. We won't do that. We're not doing that. We're knowing how to do this conceptually. You will not calculate. I think the question was, how do you find beta? You will not calculate beta. But here's the thing you should know for certain. Let me write this right here. Alpha and beta are not complements. Did everyone hear that? Repeat it. Alpha and beta are not complements. This is a summary of this. Please put this in the chat. Alpha, understanding the concepts. That's correct. You will not do calculations of beta. You have to have all the components and run it through formulas and solve the curves. It's a little more mathy than we like right here. We want you to know why you're doing this. If someone told you this test is not powerful enough, and let me explain why, and they're not complements, great job. And I'll explain why this matters and why you would need to know it. And I'll explain the usage case of it, which we care a lot more about in this class than doing a math calculation. Alpha and beta are not complements. Increasing sample size increases power. Larger effect size increases power. We don't really control that. Increasing alpha, which we do control, increases power. Your friend, or you work at a company, and they want to see if a new website design is better than the old one. A statistician tells you that the test is not currently powerful enough with 2 days of data. What is your suggestion? Just think about this conceptually right here. Like, we could run it through and run the power calculations, but you should know this conceptually right here. It should be a pretty easy to be like, okay, you're saying it's not powerful enough with 2 days of data. What would you say to them then? What would be your suggestion to them, knowing the concepts? Increase, we need, okay, let's collect some more days on this. They're telling you they don't have enough sample size to find results, even if results exist. Even if results exist, they're not going to be able to find it. Like, think of someone taking 1 drop of blood. You might really be sick, but that's not enough information to reject the null hypothesis if the null hypothesis is false. You don't have a powerful enough test. Basically, in the idea of what is power, power is the ability to find results. With 2 days of data, you don't have enough to find results. So a powerful test can find results. If you have a test that's not powerful, you might not even run it. When it comes to companies, they run a power analysis to find out, should we even do this? So let's say the company says the power of the test is 0.10 and we can't collect more data. Should we run this test? It'll cost $10,000. So once you think about this just conceptually, the company says the power of the test is 0.10 and we can't collect more data. Should we run this test? It'll cost our company $10,000. So if you understand what power is, it's the ability to correctly reject the false null. I'm telling you, you don't have much ability. So this money right here would be whatted, because we don't even have the ability to find results. The power is really low. Even if there is results, even if there's a truth that the null is false, we'd be wetting our money right here. It'd be wasted. Power calculations are very important in industry to figure out, should you even do this? Industry uses power calculations to ask the question, should we even collect data? Should we even run this analysis? And it's not, if you have the numbers, you can just run the numbers. But companies like Eastman or Pepsi or Frito-Lay are going to say, okay, we have to shut down machines. We have to collect data for weeks. We have to pay the statisticians. We have to pay people on leave. And it's going to cost us $10,000 to do this. The test is not powerful. It's a waste of money. And that's why we do that. You want power to be close to 1. And don't cheat with your alpha, because then you'll make too many type 1 errors. So if you increase your alpha, you're trading off type 1 errors to say there's results when there's not, which is rejecting the true null. The correct hypothesis is low. Exactly. And so Caitlin might be saying right there, if you increase your alpha, you'll make the other error. So you don't want to, it's a bad idea to increase your type 1 error to get your type 2 error lower. Like, that's a bad trade-off. Usually you keep to the 0.05 alpha, but you can change alpha. So hopefully this makes more sense to people on why we care about power and why we talk about it conceptually here, because statistical software will just output the number for you. If you found out the power was this, and it's a very important thing, we'd be like, well, cool, this is a really powerful test. If there are results, we'll be able to find them. And that's what power is conceptually. We have a 99% probability of finding results if results do exist, i.e., if the null is truly false, we will be able to correctly reject it 99% of the time, given the variation in the data we expect. So once again, it's just, can we find results? It's very likely that we'll find the results if the results do exist. That's what power is. Let's do at least 1 or 2 more concepts, but that's the theory behind it. That's everything we need to know. Back to the main screen. Okay. Does anyone have a concept? I've got 2 more. I've got alpha and, well, we just did alpha and beta. We've got interpreting tests, but what's the last stuff people want to do? Do people want to do interpreting tests before we start some Kahoot? So that was a good 30-minute section right there. What do people want to do? You take your pick. Got the last of the coffee. It is. Let's do an interpreting test, Josh. Is that what you'd like? Should we do interpreting test? Josh wants interpreting test. Should we do 1 sample t, 2 sample t, chi-squared, proportions? What shall you pick? 1 sample t, 2 sample t, chi-squared, proportions. Take your pick in the chat. So we'll do a vote. Where's my vote button? 1 prop Z. 1 samp T. Sample T. 2 sample T. Cost squared. Test of independence. A lot of people saying 2 sample T, so it looks like we're going 2 sample T. Okay, 2 sample T. We'll get some jump output going right here. So let's put in interpreting 2 sample T. It looks like that's going to win right there. So I'm just going to go with it. Interpreting tests. 2 sample T. Okay. 2 sample T is winning out. Let's go to the main screen and do it. Okay, so we're going to interpret a 2 sample T test. Now, whenever we say a T test, the Y variable in a T test is what? Whenever we say a T test, the Y variable in a T test is what? So if we say a T test, as soon as we think about the variable of interest that we're analyzing is a what? It's quantitative. Mr. T is mean. You'll hear me say that all the time. He's a super nice guy, unless you're doing drugs. So the Y variable is quantitative, and the X is categorical. So Leo's got it right there. Great job, Leo. More points in the chat. We have right here, let's look at how many hours people work. That's quantitative. The blue means quantitative right there. And then let's look at based on if they are an honors student. I know honors student is on here somewhere, right? There you go. You can actually search. I think it's a new thing in the newer jumps. So when you look at this right here, why is it called a 2 sample T test? I want you to think about why it's called a 2 sample T test. Why is it called a 2 sample T test? Just go on the theory on why it's called 2 samples. There's 2 samples. We have a sample mean for yes. We collected students who are in the honors program, yes. And we have students who are in the honors program, no. This line right here is actually the grand mean, which is the mean of all the data. You don't need to know that. Hopefully no lag today. Hopefully. Darren, stop messing with our internet. There are 2 samples. A sample of those in the honors program and sample of those not. Great job right there. So people are confirming lag. First lag of the day. Hey, we'll take 1 lag. Only 1, though. So we're going to go here to t-test. It does say t-test, but it's not just a t-test. It is 2 samples to compare the 2 samples. And we do see a difference. So let's talk about how to interpret these results. And I love multiple things on this. Okay, this is really good. Okay, so I'm going to put up the blank screen. How long was the lag for? Was it like just a second? I made some changes that it actually tries to reconnect within 1 second. I'm going to blank out some stuff right here, so give me a moment while I blank this out. Well, let's do our usual. Was it just like a real quick blip? Because that was my goal when I made some changes to it. Short little blip, good. I have it so it reconnects after 1 second now. It actually used to try to reconnect after 3 seconds. I've done a different bind to IP test. Literally 5 frames, the lag was short, cool. Might have just been a cool YouTube blip. I don't know. I was doing this a harder version then. We won't do a. I'm doing it in the medium version of this. I'm blanking out some output right here. Okay. Cool. Let's do this. Back to the main screen. Okay. I got the P's. Yeah, the P values and stuff. Yep. Okay, so we have blank 1, 2, 3, and 4. Okay. So take a moment and tell me blank. Well, shoot. Yeah, I guess so. Tell me any of these blanks. Blank 1 might be the harder one for people. Tell me any of these blanks. So take a moment right here. See if you can solve any of them. Priya's already on a roll right there. Which one is that, Priya? Blank 1, 2, 3, or 4? And then we're going to interpret this result right here. Blank 4. So blank 4, people are already finding. Blank 4 is going to be that both of these added up right here sum up to 1. Because you're shading above a point on the curve and you're shading below a point. So that is the 99.85%. And then this is the 0.15, also known as that as a decimal right there. So that's got it right there. Kirsten's got the T-score, right? The T-score, blank 2, yes. My brain, I thought it was the Z, the 2 is the Z. That does look to be correct, Kirsten right there. Kristen. I've said your name 1,000 times. I'm just going to get everyone's names wrong at the end of the semester. And I think Leo's got blank 3. Blank 3 right here is going to be doubling the smallest. So when you do this right here, it's 2 times the smallest p-value. So that's 2 times the smallest. You literally take the smaller one right here and you double it on the other side. So I know, right? My brain. It's rebooting from mini-term. This is the reboot protocol in my brain. And so how did you get that blank for the t ratio right here? The difference right here is literally y bar 1 minus y bar 2. That's what we mean by difference. The standard error is s sub 1 over n sub 1 plus s sub 2 over n sub 2. That's the notation for it. And if you divide these numbers, you literally get the t ratio, because this is the difference. That is the difference between the two sample means. And if you divide those numbers right there, you get the t ratio. That is the t ratio. It's basically -3 divided by 1. You know what's super interesting about this? You know this was random that we got this. Could anyone have guessed? Could anyone have guessed the p-values? The t statistic. This is just random that we got this. And this is why knowing z-scores is so important. The t statistic is basically -3. So tell me, if this was a z-score, what percent of area would be between 3 and -3? If this was a z-score, what percent of area would this be right here? If it was a z-score, 99.7. Which means outside of this is what total? This was just pure luck, and it turned out this way. Outside of this is what? And that's the two-sided. This was pure luck. But it shows how the concepts of z's and t's are very similar. Why is the t basically like the z right now? Who can explain conceptually why the t is basically like the z? There's another thing. We're looking at the full output right here. We've talked about pretty much everything on this. We're missing one blank. But why is the t basically like the z right now? Well, it's basically like the z. The t and the z are virtually identical now because why? Did you see it in the output? Because, look at the output again. The t is calculated more accurately, and the t has a shape that's based on the degrees of freedom. And the more degrees of freedom a t has, the more like the z it is. Does that make sense? That's basically the normal curve. But the less degrees of freedom it has, the less normal it is. Notice how we have the 1.96 usually for the z-score, and our degrees of freedom here are 132, which is a lot of degrees of freedom. At this point, it's very similar to the normal. So higher degrees of freedom, the more like the normal it is. Notice how this is 1.96 with 5% on the outside. Well, if we go here to a large degrees of freedom, it literally says 1.96, which is the same as the normal curve. So we have a pretty high amount of degrees of freedom, and that controls the shape of the t, and this is pretty normal right here. So this is kind of like using the z-scores, but the t is more accurately calculated by William Gossett, who worked at Guinness Beer. Make sure you know that. William Gossett worked at Guinness Beer. Has anyone figured out number 1, which is the only thing for us to figure out left on this? I will take a quick estimate of it. Just quickly estimate. The way to figure out blank number 1 is the following. We are looking for the lower of the interval. So we're looking for the lower bound of an interval. We need the estimate at the center. And we know the upper bound of the interval. So the upper bound of the interval is -1. That's the upper bound, or maybe I should put it over here. -1, and this is the upper. Who knows the lower bound of that interval? Well, it would help if we knew the estimate. We can just round these for the time being. It would help if we knew the estimate. What's the estimate? Who can tell me the center of the interval, which is the estimate? Because think about what we're trying to estimate. Close, Leo. First off, what's the estimate, which is the center of the interval? So if you look at your interval, it's y bar 1 minus y bar 2 plus or minus, and then t star df, and then we'll write standard error df, or standard error diff. Abbreviate that. The center of the interval is the difference, right? And the difference is -3. So we've literally figured out the difference right here is the estimate of the interval. And so now we could figure out the what from this. What could you figure out using this information right here, which I'm highlighting for you? What could you figure out conceptually now? Great job, Josh. Josh, seen it. What could you figure out right now? The margin of error. So now we know the margin of error. And what's the margin of error on this? The margin of error, which I'm highlighting here conceptually in green, the margin of error is what? Just round the numbers, do it nice and neat. The margin of error is basically what? And great job, Troy, right there. It's 2. So the margin of error being 2, and you could find the margin of error more precisely. Here we'll write 2, and we'll highlight it in green. The margin of error being 2 means we just need to go plus or minus 2 on this. So that's -2, and that's +2. And so think about this. It's just going to be -5. If you want to find that out more exactly, then subtract the numbers right here from the difference to the lower. So 3.0923 minus 1.0. There it is right there. So 3.0923. It's going to be negative. Make sure it's negative. -5.1159. And there it is right there. And it does more exact calculations. Oh, there it is right there. So basically in the negative version of it. Does that make sense, Leo? And if you use the rounded numbers, just think of it as, once again, it's easier if you round it, just for the time being to show the theory behind it. And I'm just going to blank that out right there. Does it make sense to look at this? If you look at these numbers now, you can see that -3 and -1 have a distance of what? Can you go over which one again, Avery? So this has been more interpreting jump output than it has been interpreting the test. Ooh, you're next. So let me change this. Can you rephrase the question? And Laura, great job right there. The margin of error is 2 right there. You can see it, that -3 plus or minus 2, and that's what you're looking at right here. We remove the decimals to make it easier to look at, just so we can see like, oh, -3 is the estimate, which is the center of the interval, and we just have it color coded right here in the equations. This is the test version of it. This is the interval version of it right here. Find the margin of error. So if you want to find out exactly, we could do upper what? So tell me the mathematics right here to find the margin of error, just theoretically. Theoretically, to find the margin of error, if we do not have this info, how do you theoretically find this margin of error right here? How do you theoretically find it? And you can do that, Caitlin. That is correct. It's half the length of the interval. Great work right there, Caitlin. We often do half the length of the interval, but let's say we don't have the full interval. So let's say we don't have the full interval, which we don't have on the screen right here. That'll be the center, Avery, right there. That's the center of the interval. And here, let me do an example with this. Right now, with the information on the screen, you'd have to do what? What would you have to do right here on the screen? With the info you have on the screen, you currently only have the center of the interval, and you have the upper of the interval. So does everyone see? Just think about mathematically what you do to figure out this right here. So we can see the answers on the screen, but think about it. If you only have the center, oh my gosh. If you only have the center of the interval and the upper, then it'd be upper minus center exactly. Just how far away is the upper from the center, which is half the length of the interval. Great job, Kristen right there. Solve for the lower. You could solve for the lower, but right now, if we just want to know the margin of error, so the difference is the center. That is correct. The difference is the estimate of the center of the interval, because we're trying to figure out the true difference. So our best guess of the true difference is the sample difference. I always like doing, so let's do confidence intervals right here. Confidence intervals, finding centers and margin of errors. Okay, so this right here. Okay, let's talk about confidence intervals, finding centers and finding margins of errors. Now, I always like to start. We're going to do jump output in a second, but I want you to see conceptually how to do these. Here's how we do it conceptually. My friend told me we're going to go to a fancy steakhouse, and the fancy steakhouse is going to have a dinner that costs between $30 to $40. How much did my friend estimate the dinner to cost? How much did my friend estimate the dinner to cost? He said it's going to be between $30 to $40. And the estimate is the center of the interval. So we have right here, at the center of it is 35. And this is what is called the estimate. The other things are called the upper and the lower bound. So this is the lower bound, and this is the upper bound. So when you think about this, so what is the margin of error? Now, margin of error is always written as a what or what. So the margin of error is always written as a what or what. So try to solve the margin of error right now. The margin of error is always written as a what or what. And I guess I'm trying to do it here visually. That works, I guess. The margin of error is 5. Great job, Gwendolyn and Caitlin right there. The margin of error is 5. So we'll start the Kahoot here pretty soon in about 10 minutes. It's the plus or minus on the interval. So write this as an interval right now to say, oh, my friend told me it'll cost this plus or minus this. Like, they thought it cost this, but what? Like, instead of saying between $30 to $40, we could say this or this. 35 what? 35 plus or minus $5. That's the margin of error. Like, they think it's going to cost 35. That's their guess of it. And then the margin of error here is plus or minus 5. So if you think about the way we can calculate this, the margin of error is always half the length of the interval. So there's a lot of formulas for margin of error. Here we'll do margin of error right here. Margin of error most commonly is how big is the interval. How big is the interval is upper bound minus lower bound. And then we divide that in half because the top of the equation is just the distance. Does that make sense? The upper bound minus the lower bound is what in this equation? Like, just tell me upper bound minus lower bound mathematically is what? Just think you're finding how far those numbers are apart. The upper bound minus the lower bound, and if you subtract them the wrong way, doesn't matter.
It doesn't matter!
Because it's just plus or minus at the end of the day. So you're just figuring out how far are those numbers away, and then what's half that distance. And that's literally what you're doing right here, half the length of the interval. Now, there are other formulas that we don't use as much, but they could be used, such as like upper bound minus center. And if you look at this, upper bound minus center, this is formula 1 you could use, formula 2, because the upper bound minus the center is already what? The upper bound minus the center is already what? Or which is the estimate. I called it estimate. The center of the interval is the estimate. They're synonymous. We'll put est for estimate. The estimate minus the lower bound, and I don't think there's any forward. It's already the margin of error. It's already half the length of the interval. Like, if you go upper bound minus estimate, well, it's 40 minus 35. That's half the length of the interval. If you go estimate minus 35 minus 30, that's already half the length of the interval. So those are other possible formulas. The center. Trying to think. There's the most classic formula for the center of the interval is going to be what? The most classic formula for the center is if your friend tells you it's going to be 30 to 40, you should do what to those numbers? Just think mathematically right here. If your friend says it's going to be between $30 to $40, you should just what those numbers together. Says 30 to 40, you go boop. Careful. Average them, right? So if we average two numbers, you say, okay, 30 to 40, what's the center of the interval? Always try to think of it conceptually before you memorize an equation. The best way to kind of figure out an equation is to be like, what am I doing if I'm finding the center? Well, I'm averaging the numbers. I'm finding what's in the middle of them. So the conceptuals can really help with kind of knowing how to use the formulas. And a small example right here with numbers that are easy to calculate is also going to help. So we would take the upper bound plus the lower bound, and you average two numbers by adding them together and dividing by 2. Does that make sense? You average two numbers together by adding them and dividing by 2 because it's the amount you have. There's other formulas which I wouldn't use. I mean, they're just not as common. You might have to maybe theoretically do one. It's possible, but knowing the theory, what would be the center would be the lower bound plus what? Just think mathematically. If you're at the lower bound of 30, how could you get to the center or the estimate of the interval? Lower bound plus what? So just think, you can see the numbers on the screen. So the lower bound plus what would be the estimate or the center of the interval? Plus 5, correct, right? So it would be the lower bound plus the margin of error. Or the last one right here is going to be another possible formula, which just not commonly used, would be upper bound what? So think if you're at 40, just get to the center right here, the estimate. So upper bound what? And so you're figuring it out conceptually just by looking at it right now. Upper bound minus the margin of error, exactly. And then you can plug in your numbers right here to see that 40 minus 5 is 35. So this is really good conceptual stuff right here. And then kind of use this knowledge, if you draw it out right here, especially with these examples, just to see how it works on numbers that are easy to use. We'll go over here and we'll interpret those results in a second. But let's get a tiny bit more jump output up and look at a confidence interval that we have to do where we have to like maybe figure out some numbers on it. It's gonna have a ton of decimals, isn't it? Let's do pet expense. 2 seconds. I'm getting some output from jump right here, and then we'll interpret that test result to finish off. Then we'll start up some Kahoot. Okay, so I'm blanking out some. What kind of jump output do we need to know how to calculate? 1 sample t, 2 sample t, chi-squared, and 1 proportion. We've done a lot of it. Great questions right there, Avery. Okay. Let's do this right here. Find the lower bound of the interval. Find the lower bound of the interval. Right now, we have the center of the interval, which is the mean, which is y bar. This is a 1 sample t. 1 sample t is y bar plus or minus the t-score by degrees of freedom, by the confidence level, times the standard error. So find the lower bound. So who can find the lower bound right here? I'm trying to estimate in my head. Well, what would you find first? So we're looking for the lower bound right here. We already know y bar, which is the center of the interval. Who's got this? Good conceptual start here. Color coding as you try to figure it out right here. Are the questions on the exam going to be like this? Like the Canvas content or the number one way? We're doing a lot of concepts. Number one way to know what the exam is going to look like is Canvas content. Number one way. A lot of them are directly taken from Canvas content. We're doing all the concepts right here. So there's the margin of error right here. And so it looks like people are getting the lower bound right there. And we could remove things from jump output. That's quite possible. Especially, there are Canvas contents, especially the p-value ones. Those are on Canvas contents, so good stuff right there. So if you look at this, people are finding it. Do we know how many questions? 40 questions, I believe. So what are people doing right here? The first thing people have solved for, if you've solved this, is you've solved for the what. Great job, Laura and Kristen and Avery. The first thing you solved for was the what. I've drawn out here visually the information given to you, highlighting it. The first thing people are finding is the margin of error. And to do this, you're taking your what right now. How are you doing this conceptually right here using the information we've just given? You're taking what? Find margin of errors. Great job, Jennifer. Find the margin of error first, being Jennifer Ahmad. So we found the margin of error first, and how are you finding the margin of error? Think about what you have here conceptually with the color coding. So to find the margin of error right now, you're just doing the upper minus the mean. And so let's take the upper bound, subtract the mean, and there is the margin of error. So we know this is 92.16. And now what do we do to find the lower bound? Just simply, what do we do to find the lower bound? And then we're going to interpret the test results here. Or, well, I might show it. We've got a lot of good videos on interpreting test results. Now that we know the margin of error, this literally is the margin of error. We're just going to do the center of the interval, which is the mean, great job, Lily there, and subtract the margin of error. So we're going to do the same thing, but we're going to go down the margin of error right here. And we're going to subtract 92.16. There it is right there. And that'll give us the lower bound right here, and we'll show it visually. So the lower bound is what we were looking for, and we're just going to take the margin of error and subtract it from the center of the interval. Very quick conceptual question. If Brian had built a 90% confidence interval, would it be wider or tighter than this interval? If Brian had built a 90% confidence interval, would it be wider or tighter? So would a 90% confidence interval be wider or tighter than this interval? 90%. Be careful. So always do it this way, Avery. Here's the trick. You ready? Here's the trick to it. When we do confidence intervals, say it this way. 68, 95. And as soon as you say this, what do you notice happens? If you go from 95 to 90, the interval would get what? 68, 95. If you go from 95 to 90, you're bringing it in. Does that make sense? So when you go 68, 95, no, don't worry. It's so easy to mix up. But I like doing the things like that where we say 68, 95, 99.7. That's when we're talking about the area contained within a certain amount of area on the curve. So it works for either the T or the Z. We're going to show it here second visually, but it's tired because you have less confidence. Exactly. Think about this. If you were more confident, you would cover more values. Like conceptually speaking, David M. Lane's down? That's weird. Good thing we're not using much. You can go here. It's tighter because to get more confidence, you would include more numbers. Exactly. Tessa's talking the theory behind it right there. Mary's doing some of our new commands. So we can go here to the normal and go to a 68, 95, 99.7. The more confident you are, the more distance you cover on the curve. So to be more confident means to cover more values on the possibilities. But yeah, we've done a lot of good review today. I do want to point this out. We did interpretations of tests a few days ago where we were going over here and going over each interpretation of each test, where we're talking about rejecting or failing to reject the null by saying I reject or fail to reject the null. Please, 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 if you're watching, we might have more people watching right now. I think we're up to, saw there was like 50 votes on that last thing. Please go check out the videos we have listed right here. Let's go actually over to the YouTube channel, where we have right here solving a one sample t-test right here. And you'll notice we go through and we do each step. The wider the interval, the less accurate it is. The wider the interval, the less precise it is, Lily. Wider intervals are less precise. So wider intervals are less precise. How could you make an interval more precise without changing the confidence level? How could you make an interval more precise without changing the confidence level? So y bar plus or minus t star and minus 1 s. Or how could you make an interval more precise without changing the confidence level? You can use your calculator. How can you make an interval more precise without changing the confidence level? Increase sample size. Increasing the sample size right here decreases the margin of error. So this is the margin of error. And in all the equations, n is on the bottom of the equation. So if you are in the denominator for standard error. So if you have y bar 1 minus y bar 2 plus or minus t star, then the n's are still on the bottom right here, s sub 1 squared over n sub 1. Notice how it's on the bottom, so increasing n will decrease this value. And last but not least, the other equation we have is p hat plus or minus z star, no degrees of freedom on the z, p hat q hat over n. And just notice where n's are in these equations. They're all in the bottom, telling us that if we increase the sample size, we decrease the margin of error, just so it gives us a better understanding. Doesn't change the certainty. The certainty is controlled by the what, CV of it. The certainty of these intervals are controlled by the what. So the sample size, and we'll do Kahoot here in a half second. The certainty, like I am blank % confident, is controlled by the what. And then we're going to have her to Kahoot. The I am blank % confident is controlled by the what's of these intervals. The I am blank % confident, which is why we put a star on them. The critical value of the test statistic, great job Alexa right there. The critical value of the test statistic controls the I am blank % confident. Every interval always has a what with it. Every interval always has a what? Every interval always has a what? So all those things are my whats of the value I'm trying to understand. It's the center of the interval. Every interval always has a what? A center, which is my estimate, right? So that's the estimate right here. So every interval always has an estimate, what we think is true. And then every interval always has a what afterwards. After the estimate comes the what. For every interval, after the estimate comes the what. For every interval after the estimate comes a margin of error. Hopefully this helps you connect the topics to understand that if sample size increases, margin of error gets smaller for all these. The T or the Z control the percent confident we are. That's part of the margin of error. The center of the interval is your best estimate of the truth right there. And you could think of this. Just really quick before we do the Kahoot. Let's do 2,000 points. Brian is trying to estimate the true what for his regression, the true what of his line. Brian is trying to estimate the true what, and this is an actual equation. Brian's trying to estimate the true what for 2,000 points. Brian is trying to estimate the true what, and that's an equation. That's an equation to estimate, not the mean. So sorry, ignore this question. This is not on your test, but this is 320 right here. What's B1? I'll write it out. This is not true proportion. Don't worry, I shouldn't have done it maybe. Ava earning everyone 2,000 points. The true slope. Brian's trying to estimate the true slope. Don't worry. Don't look at that. But what do I want you to see from this? What do you think Brian wants you to see here conceptually? Conceptually, what do I want you to see on this? What is the important concept which could help you in other classes? It's just to show you that this is used elsewhere, that the concept here, our estimate of the true slope is the sample slope, and then we have a plus or minus. It's an estimate. This is not on the exam. That's not on the exam. But the concept of it, how when we do intervals, we have an estimate plus or minus a margin of error. Does that make sense? The T is on the exam, but the estimate of the true slope is not on the exam. But just showing that this concept right here, that an interval starts with an estimate plus or minus a margin of error, is on the exam. And this carries over to my other classes. So if you do take 320 with me, same way we do it right there, same exact way. So with that, I think we have, who's ready for some Kahoot right here? Can I get some Kahoot in the chat? Who's ready right here? Let's head over to the main screen and get ready for some Kahoot. We're here to learn the concepts. Elizabeth's ready for some Kahoot. Ford's ready for some Kahoot. Leo's ready for some Kahoot. And great job, Ava. Excellent work. Ava, have you ever done that elsewhere? Have you done more regression? Regression is a super important concept used throughout many classes. Jasmine, great to see you. Alexa, great to see you. Javen, great to see you. Regression is super crazy important. Just one of the bread and butter of doing statistics. Who's done a regression in another class? Has anyone done regression in any class outside of 201? Like maybe it's economics or biology. Regression's very important. Very important topic. Anyone done regression? Anyone besides me? Maybe no one else does it. Maybe it's old. Maybe we shouldn't teach regression anymore. In Psych 298 class, yep. Psychology uses regression all the time. We did them in Bio 160, yep. Econ right there. Regression is just, if you told someone what is regression, you would say, oh, you're just putting a what to data. What are you doing? Regression is just what? Just putting a what to your data, which means you need two quantitative variables. Me and a couple psych courses, exactly. Say, oh, it's just adding a line to the data. You just take two quantitative variables and you fit a line. So that's all it is. This was regression. Just the equation of a line to predict data, a trend line. Exactly right there, Clara. Great work. So that's what we have. That's what regression is. And updated 5 months ago. Exam 3. Let me double check, make sure. I want to choose the right exam. Well, that. Oh, wait. We're gonna start here in a second. Let's play one last song right here. What are people doing this weekend? We did Kahoots, right? Bunnies. What do you think, Brian? Cramming for the exam, getting ready real quick. Could you let us know if we need to know the goodness of fit test on the exam? Goodness of not as important. I can't think of any questions that use it, Avery. Goodness of fit test tests to see if a distribution is normal or not normal. That's a goodness of fit test. It sees if the normal curve is a good fit. Oh, Javen, it's almost over. Almost time to relax. I've been horse sitting and farm sitting all weekend. That's awesome, Tessa. Red Bull Summer Edition. Clara, I think we might go to the grocery store today. And Clara, let's throw some 100 points. I think Brian's going to get a Red Bull Summer Edition. I forgot it was Friday. Wait, it's Sunday, right? Maybe eat at some point. Eat, enjoy, get good sleep, relax, and have a great evening. How do we submit our bonus points? Oh, yeah, I need to send out the reminder. Fill out the quiz on Canvas. There's a quiz on Canvas. Pickleball? What is that? It's a Sunday, my guy. Bacon cookies. Oh, my gosh. Game 7. What is it? World Series? Let's get the start of Kahoot. Okay, Celtics versus Bucks. Ooh, Celtics are in the series. Does Shaq still play for the Celtics, or is he retired yet? I'm stuck in 2012. Oh, I know Shaq's retired. Don't worry. No, you're tired. Long gone. How about Nate Robinson? What's Nate Robinson up to these days? Is he retired? I think he's retired too. I did watch some Celtics for a while. No, you don't have to log into Kahoot. Oh yeah, he did some boxing stuff, didn't he? Fought Dr. Mike, maybe. Dr. Mike doing boxing, beating iDubbbz, I believe. Craziness. Let's log in. He fought Jake. He did fight Jake Paul. Wow. Let's over to the main screen. 1:40:10. It is time for Kahoot. Bring the music down here a little bit. Oh my gosh. Probably a size difference right there. We've got the Kahoot ready to go right here. Mighty Impala to start us off. Join in. Let's start. What do we need to submit on the quiz today regarding the Discord? How many points you have? You can go to the rank check on Discord. So you would go over to Discord, check your rank on Discord. Make sure you're doing the rank check channel. Captain Gator on top. Oh, Leo's Captain Gator. Can we get 100 people in the Kahoot? Can I see 100 people in the Kahoot? Let me get everyone right here. Oh, did Kristen put that there? Stop. Thank you, Kirsten. Right, Kristen. Why do I keep saying Kirsten? I don't know what's wrong. Let me message allstat201 and say Kahoot starting now. And okay, I'm just gonna shout it. And then let's grab the time. Let's grab the video. Okay, so we'll see if we can get a few more people. Say no, I don't want anyone else in here. Don't want anyone in here besides us. We're here to win. Thank you so much, Kristen. I don't know what's up. Who is this Kirsten? Is there another Kirsten? That's the other Kirsten right here. Do we have a Kirsten? No, wait, didn't. Who is this Kirsten person? I thought there was like a last name. I am the mighty gazelle, Dr. Hamster. Champion Zebra about to go off right here. Good to see her, Luke and Ford. We're going to put a 2-minute timer on, so once the 2 minutes ends, we are starting. 2-minute timer has begun. 2-minute timer. Space. Jalen. You know my affinity towards the bunnies. Are these like exam questions? They are. They are. Dr. Hamster in the Multiverse of Madness. Troy, let's take that and make that a quote. If you didn't know, Mubot knows tons of quotes from all the amazing things that have been said. Quote 217 is now Dr. Hamster in the Multiverse of Madness. If you want to look down a history of Stat 201, just type in !! Quote. Decisive order is not fitting me, but but check out any quote. This is slander to y equals mx plus b. I can't remember. This is recorded. That's right, Tessa. You can go back and practice these right here. We're just seeing the Mubot Multiverse of Madness right here. The final bullying of stats. That's from this semester. In stats, to increase your confidence, you widen your interval in life. To increase your self-confidence, you widen your comfort zone. Mubot offering some life advice right there. Nice to everybody. All the jokes, all the points. We've only got a few more seconds on the clock. 49 seconds till we start. Sumo Santa. We bully exams. Do what Brian says, not what Brian does. Brian's usually right, but sometimes too right. Do not write. I think a student said that. Do not write everything Brian does when doing the assignment. Do what Brian says, not what Brian does. Too crazy. Good to see you, Benjamin. What time is the exam? It's double check. It's on Canvas. Remember, we are starting here in a moment. We got the peel drop, and we're starting here in 20 seconds. I'm sorry, Miva, I think I gave that backwards. Awesome. Starting here in seconds, 10 seconds. So if you didn't log in, get ready. Remember, $30. Please email me if you win, saying I want an Amazon gift card. I want a Starbucks gift card. That's the bell right there. Thought today was Friday. I know, right, Avery? We don't have classes. Only 50 people. That's all right. We're early for the exam. People are saying, exam's Wednesday. But don't worry. We'll be practicing here. My concept of time's off too. Here we go. We're starting in 5. I need some I'm raising the chat. 4. I need some I'm raising the chat. 3. I need some I'm raising the chat. 2. Can we get another person? 1. Here we go. Let's Kahoot. I'm raising the chat. 3, 2, 1. Here we go. First question is, how would we test to see if there's a relationship between being married and non-married students and how old they are? So we want to test students who are married and not married and how old they are. There's a tools and techniques question. So tools and techniques give you variables usually, and then you want to see if you know how to do a test with it. If you're really knowing how to do this, then think about what graphic you would use. Who in the chat can answer what graphic would you use to compare the married versus the non-married, 2 groups right here, and their age? What graphic would you use? So in the chat, try to answer this additional question. We throw out additional questions here to practice. What graphic would you use to compare? Side-by-side box plots is correct. Great job right there. Side-by-side box plots. That is one way to do it, or stacked histograms. Pivot's kind of an answer to everything. 2 box plots, side-by-side, exactly. And the reason being is you have a what variable here. And wow. That's really good. You have a what variable right here. What are your 2 variables? So what are your 2 variables? Age is what? Put Q or C in the chat. Age, you have a categorical variable with married, not married, right? And then you have a quantitative, how old somebody is. So if you look at the way this is, you have a quantitative variable with how old somebody is. And then we have a categorical variable on married, not married. So you do side-by-side box plots. You're going to compare the average age of the individuals. So it's a 2-sample t-test. You'd have a sample of people who are married, and you'd have a sample of people who are not married, hence the idea of 2 samples. And anytime we say T, it's because the Y variable is what? Anytime we say T, you're just repeating yourself right now, but if you say T, it's because you're analyzing a Y variable that is what? Mr. T means quantitative, right? Yep, and don't worry, this is rapid fire. I was playing a Kahoot that I didn't make with my students, and I got one wrong. I know the anxiety. Remember the exam, just take your time and review your questions afterwards. Mr. T is mean if you're doing drugs. Who's in the lead? Captain Gator. Did Captain Gator say they were going to be in the lead? Wow. We got Epic Hen, Bold Squid, Decisive Otter, and Swift Koala. Swift Koala, Captain Gator on top. Super, wow. I think it's like, that's like less than 1/10 of a second. Woo! Here we go with the next question. Let's do it. How can we test a relationship between someone owning a pet and if they're married? So you have, do you own a pet and are you married? So once again, while we're doing this right here, we're talking about the test we would use, but I also want you to think about what graphic you would display this with. So this is the additional question right here that we're considering while the timer's going. First, try to answer this on the screen and then try to do the additional one. How would we display this graphically? So first, great job, Avery, right there. Think about what variables you have. You have, does someone own a pet? Yes or no. So that's categorical. And then we have, are you married? Yes or no. So we have 2 categorical variables. Now that means we're actually doing the condition count data has been met. So if you think of the condition count data, and people are putting some awesome answers in the chat right there, count data is the condition for the chi-squared test of independence. Not that I'm giving away the answer for this one, which I am. But the chi-squared test of independence is when you have 2 categorical variables. Ooh, we caught a lot of people on this one. So let's just see it in the output right here. Anytime you have 2 categorical variables, like are you born in Tennessee and are you in Greek life? So what is the number one way to answer questions for tools and techniques? Figure out the what's. What is the number one? Yep. Here, Jane Carson, there's the code right there. You can join in. So it's right behind us right there. Go to kahoot.it and enter in the pin. So what is the number one way to get these right? We had a lot of wrong answers. What is the number one way to answer these right here? What is the number one way to answer these? The number one way to answer these is to figure out the variable types. We went over tools and techniques in the first video, and here it is right here. Here's a review. We put the conditions, but these are the conditions: quantitative, 1 sample, 2 sample t. This might not be the best, but we were talking about tools and techniques at other points with the chi-square test of independence and things like that. So check out the earlier videos. But if you see a question asking you, what kind of test would you use? Figure out the what's. Repeat it in the chat. Figure out the what's. And Nate, Troy saying right there, we have 2 categorical variables. So that means we're doing chi-square test of independence. Figure out the variables and how many you have. That's going to help you decide. The chi-square test of independence is 2 categorical variables. The 1 proportion z test is 1 categorical variable. The 2 sample t, which was the previous one, is a quantitative y and a categorical x. The 1 sample t is 1 quantitative y. Chi-square test of independence is chapter 19. And we did tools and techniques, I think, in the first review. Everything's labeled, Samuel, so make sure check it out. Everything will be labeled in each of the review videos. Check out where we went over a good bit of tools and techniques. Went over all the graphics and all the tests. And did example questions. So let's do the next one right here. Who's in the lead? Captain Gator. No longer on the top. No. That's all right. We've got here Mystery Pony, Bold Squid. Where's the bunnies at? Epic Hen. Great job. And Decisive Otter and Mighty Gazelle. Next question. Here we go. Question 3. When doing a hypothesis test on the mean, which is a condition that must be met? So when we do a hypothesis test on the mean, what is a condition that must be met? So start here. We know those conditions. Well, you're like, dang it. I was all ready to say. Condition 1 is random. We need to randomly collect observations. That's one that always exists. Condition 2 is 10%, which means if we're talking to UT students, we need to collect less than 10% of UT students or any population. But now we pause. We put some pause in the chat if you'd like. And we ask ourselves, what kind of data are we working with? And since we're working with the mean, we want it to be nearly normal. These 2 conditions down here are for what? These 2 conditions here are for what? These 2 conditions are for what? So these 2 I'm highlighting down here on the bottom. Expected cell count and count data are the 2 extra conditions for chi-square test of independence. Success failure is when you have categorical, and the nearly normal, which can be checked via large enough n, the nearly normal is quantitative data. So when you have quantitative data, nearly normal. When you have categorical data, just a categorical variable like confidence intervals for the true proportion, testing the true proportion, success failure. And when you do this right here, great job, Kristen, back on the podium. When you do the chi-squared, you have these 2 conditions. What one condition is missing from the screen right now for 1,000 points? What is a condition on here for the 2 sample t-test that is missing from the screen that we want the 2 means to be what of each other? What condition for the 2 sample t-test that when you say are like, oh, you want the 2 means to be what of each other? Independent. The 2 sample t-test has the condition independent means. So this mean is independent of this mean. As in like, let's say I'm testing someone's weight loss before and after a diet, then their weight after the diet is going to depend on their weight before the diet. But let's say we're testing 2 different weight losses with 2 different groups of people. Then people who are in weight loss group A and people who are in weight loss group B are independent of each other. Before and afters are usually where we violate the condition of independent means, where it's like your weight after a diet is going to depend on what you are before the diet. But check out the videos. We're going into more detail on the conditions. Next, and I do have a video in the playlist on the review 3. Check it out where I do all the conditions and talk them over with examples. Next question. Epic Hen. Oh, the leaderboard's oh no, the leaderboard's not locked up. Decisive Otter taking the lead. Bold Squid and Epic Hen still right there with Decisive Goose and Mystery Pony right there. Yo, good to see you here. Oh, pin. Yes, the pin is right there in the corner. Curio, great to see you here. Join on in. Let's see. Next question. The pin's down there in the corner. Which condition do we need at least 5 of? Which condition do we need at least 5 of? Yeah, MG's just like, and the Kahoot. Hit the end button, Brian. $30 for the winner, $20 for second, $10 for third. Avery, you're fine. Don't worry. So the at least 5 applies to the which test? The at least 5. Tell me the test right now. You're saying for this test, there's a condition where you need at least 5 of these. What's the test? The chi-squared. The chi-squared test of independence has at least 5, and you need at least 5 expected cell counts. So count data is also a condition, but that just means you have 2 categorical variables, which you literally have to do chi-squared. If you don't have count data, you're not doing the chi-squared test of independence, categorical data. The expected cell count right here. So let's look at just a little bit of jump output to confirm this. Do we meet the expected cell count condition? Where's the smallest expected cell going to be? Is it yes? Here, let's put some numbers on this. Be careful. This is a good trick question. Oh, darn it. I want to do one where it's not. Give me a half second. Good. No, it's always. Darn it. Let me try to do one more. I'm trying to find one where it doesn't go exactly where it looks like. Okay, so let me try this. And it's going to go exactly the same. Okay. Let's find an expected cell count for the following table. This is stuff very important to the test. How do we find expected cell counts right here? Really quickly, we're throwing a lot of good questions in here. How do we find an expected cell count? Let's find it for the following cell. How do we find it? Take a moment right here. It is on the formula sheet. Remember that it's row total times column total over grand total. The best way to do this is to literally circle the numbers you're working with. So you're going to go in here and do the column total, the row total, and the grand total. So those are the values we have, and we're going to circle them. Row total times column total over grand total, and that is the equation. Priya right there has already figured it out, it looks like, and we're going to plug in the numbers and solve it, but look how it like zeroes in on that cell. So we have 319 times 288 over 806. And if you got the same answer right there, you've been doing it correctly. Yeah, I mean, sometimes we review them to see if there's issues. It's, I mean, you think about it, like, I've got 700 students, and if each one takes 50 minutes, that's days worth of recordings. It flags stuff, you know, just don't cheat. If you don't cheat, we're very against making type 1 errors, if you get what I'm saying. So great work right there, everyone. That's how we get an expected cell count, row total times column total over grand total. What is the F squared cell? Was that in the output, Ava? You said the F squared cell? Ava, can you repeat that? What is the F squared cell? Did you always pick the lowest? Generally check the smallest dem we do. The test might have you check different ones. All eyes, you're watching. Yeah. Don't worry. Like, we're not about type 1 errors in our class. We're not about type 1 errors. We're not about being like, you cheated. If we come to you, we're going to be super duper certain. And then MG, you're finding cell chi-squareds. So MG right there is taking and finding a cell chi-squared, which would be the observed minus the expected squared. So let's take an observed, which is the count, which I can't type. Observed minus expected, square the difference, and divide by the expected. And does that make sense right there, MG? That this right here, observed minus expected squared, is the cell chi-squared. So you just found a cell chi-squared right here, which is this value right there. So that's the cell chi-squared right there. No worries, Ava. That's why I was like, F squared, that's the cell chi-squared, which is observed minus expected squared, and that's the cell chi-squared right there. And the sum of the cell chi-squareds is the Pearson chi-squared test statistic. I don't call it the F squared cell, the chi-squared. It's like a, yeah, no worries. Good questions, everybody. Please keep those questions coming right here. Let's see who's in the lead. Keep asking those questions. We're just doing, whoa, Epic and all the decisives. The decisives are after the epic. Mystery Pony and Wonderlion, good work right there. Let's continue on. Next question. Which of the following must be met for the chi-squared test of independence? So which of the following must be met for the chi-squared test of independence? So luckily, sometimes there's more than one right answer. This is conditions, and I like it because we haven't talked about conditions much lately, but this is your check to make sure you know the difference. I'm sure, I will say this from the instructor side, if anyone's wondering about proctorial right here, it does flag a lot of random things, but it gives like a suspicions percentage. So from the instructor side of it, we get like a percentage, and then we can just rate them by percentage. So I usually go and look at the highest rated videos and kind of do a scan to see if there's issues. So it just scans you by percentage, and then I rank it by percentage and check those. That's how I do my checks, because with 700 students, I'm not watching every video. I mean, literally, about every 24 students would be a day. So you're talking like I've got about a month's worth of videos to watch. Yeah, like literally if I just stay up all day, every day. Great job. Now, what is success failure used for? What kind of interval would success failure be used for? What kind of intervals would success failure be a condition for? What kind of intervals would success failure be a condition for intervals? Success failure would be for intervals for the proportion, one prop z, or one prop z test if we're doing tests. Nearly normal is always for what? Nearly normal is always for what? Nearly normal is always for like the t-test, the two-sample t-test. Nearly normal, your data needs to be what? Nearly normal needs to be means, quantitative data. No worries, Tessa. Needs to be quantitative. Who's in the lead? MG, are you still in the lead? Is it Epic Hen? This is a tight leaderboard. Woo! Look at this. Like 22 points separating, 8 points separating right there. Craziness. Next question. Here we go. Quiz question. The chi-squared test statistic is found how? How have we found this chi-squared test statistic, which is the Pearson? Don't worry about the likelihood. We don't use that one. So how have we found the Pearson chi-squared test statistic? So when we think about this, you get cell chi-squareds. Cell chi-squareds. Come on, Tessa, you got this. Cell chi-squareds, do we multiply the cell chi-squareds? Do we multiply the p-values? Do we sum the cell chi-squareds, or do we add the p-values? The chi-squared test statistic, right here, this value. First, you would have to find all your expected values. I'm not plugging the right answer. After finding all the expecteds, you would do observed minus expected squared over expected to get all the cell chi-squareds. In a three-letter word, you would what up all the cell chi-squareds? Try to remember not to do that. You would sum them up. You would add them up. Don't worry, you haven't heard from me, so you're fine. You would sum them up. You sum up all the cell chi-squareds. Let's look at this visually over here just so we can see one to show it. Think about this just mathematically right here. Here's all the cell chi-squareds. Do you see how this is point? What are all these numbers going to add up to? We've been doing this one a lot lately, but what is Brian going to find when he adds up all these cell chi-squareds right here? Before I finish adding this, I want you to tell me what's going to be in the calculator. Oh, that's awesome. Oh, that's fine, Avery. Not one. Good answer, Curio, out there. Not one. It won't be 0 either. If I'm summing up all the cell chi-squareds, 1.836. So if I'm summing up all these values right here, the sum of all the cell chi-squareds is the Pearson chi-squared test statistic. Does that make sense? The sum of all the cell chi-squareds is the Pearson chi-squared test statistic. And we just added them all up to show it. Now, once again, you would have to know all the observed, which are the counts, and you'd have to know all the expecteds to do this all by hand. But statistical software will find for you. And great job, Curio. We're great to have you. You're 100 points in the chat. Keep answering those questions we're asking them. So the sum of all the cell chi-squareds is the Pearson chi-squared test statistic. From the Pearson chi-squared test statistic, we find the p-value. No, you can join in, Riona. Great to see you right here. And there's the pin. Join on in. We're about to jump to the next question. We're going to see who's in the lead right here. It's still Epic Hen, and one of the decisives dropped off. We still got Decisive Goose right here with Mystery Pony. Getting ready for the next question. Mighty Gazelle, good to see you on leaderboard with Wonder Lion. Here we go. So begins my downfall. What is your decision regarding the null hypothesis? So here's the null. Well, that's the p-value. That's part of what you need. It's funny. If you do 1,000,000 tests, I've probably done, I don't know, I've done over 1,000 tests, I'm sure. Maybe 10,000. I'm reaching that realm. Your eyes go right to the p-value. When we do a statistical test, we need to look at the p-value right away. The p-value is going to tell us if we what or what the null. Now, you can narrow down your choices on this pretty quickly. You what or what the null. You what or what the null. You never accept. These are wrong. Don't worry if you answered these. You're like, oh no. We do not accept anything. We don't accept. We either reject or fail to reject the null. Every time we've been practicing this week, we say, I reject the null or I fail to reject the null. We've always been saying that. I reject the null or I fail to reject the null. We do not accept things. We either reject the null or fail to reject the null. So when the p-value is low, reject the null. When the p-value is high, just let it fly. What do we mean by let it fly? We mean fail to reject. So when the p-value is low, reject the null. When the p-value is high, just let it fly. Think about this. When is the p-value low? When is the p-value low? When is the p-value low? Unless otherwise stated, assume what? And I definitely review these right here. When the p-value is low, when the p-value is lower than alpha, which is assumed to be 0.05. 0.05, Brent, 0.05. Assumed, unless otherwise stated, to be 0.05. So unless this problem states 0.01 alpha, no worries, Brent, right there, 100 points, don't worry. Unless otherwise stated, p-value, and great job, Curie, right there, we assume an alpha of 0.05 unless otherwise stated by the problem. This one gave a 0.01 alpha, and we have a p-value of 0. So we rejected the null in this practice problem. So definitely check out these videos right here where we go through and we talk about, in this example, I reject the null hypothesis. We state our null at the 0.01 alpha level because the problem stated it with a p-value of 0. And Avery's talking about the confidence interval and also test connection. Great job, Avery, right there. Thank you so much, Avery, 100 points. So the way we know to reject the null right here, can anyone explain to somebody, if you look at this p-value, why do you know to not reject the null, which is called fail to reject? Why have we decided to fail to reject the null right here? Not so much. The p-value is the probability of results or results from our stream happening by random chance variation, given that the null is true. Not as important, hence why I said it quickly right there. It's higher than 0.05. Unless the problem gave an alpha level, you would look at the alpha level then and say, is it higher than alpha? But you look at this and you say, that's higher than 0.05. I fail to reject. And repeat after me, when the p-value is low, and everyone, I want you to type this in the chat. When the p-value is low, reject the null. When the p-value is high, just let it fly. You got to create a rhyme on that. Like, just let it fly. When the p-value is low, reject the null. When the p-value is high, just let it fly. When the p-value is low, reject the null. When the p-value is high, just let it fly. Does that make sense? When the p-value is low, reject the null. When the p-value is high, just let it fly. Just let it be. Don't reject it. Don't reject it. When the p-value is low, reject the null. When the p-value is high, just let it fly. With that, let's continue on to the next question. Carson, great to see you here. We got the new rhyme. When the p-value is low, reject the null. When the p-value is high, just let it fly. Continue on to the next question. But I don't think Brian... Next question. Here we go. When the p is low, we gotta go. How many degrees of freedom do we have on the... Well, it's on the output. How many degrees of freedom do we have? It? Oh my gosh. Why did I do 90 seconds? Why did I do 90? What am I doing? The answer's on the screen. How do we do degrees of freedom? We're probably going to do a mid... probably going to... It tells you right there the degrees of freedom. Now, how do we do this? We're going to do a little practice right here and do our own practice problem. You've probably answered this already. Bruce, say, Brian, that's a what by what? Well, great. I'm throwing 1,000. Thank you, everyone, for answering that so quickly and pretty much everyone getting it correct. You could read the screen. We got Clara putting the formulas in the chat, and we're throwing 1,000 points again. What's the formula for degrees of freedom, Vinny asks. So when we do degrees of freedom, we look at this and we say, Brian, that's a what by what? I want someone to say in the chat. I want you to pretend you're saying it. Brian, that's a what by what? I think you're doing for the, if you're doing k-1, that looks more like regression, or n-1 is the one sample t curio. The degrees of freedom for the chi-squared is you say, Brian, that's a 2 by 2. Does everyone see why it's 2 by 2? Does that make sense? Great job, Caitlin. It's right there, Brian. That's a 2 by 2. Now, what do we do mathematically? We subtract 1 row and 1 column, thus making it a 1 by 1, which is 1 times 1, which is 1. So just to see a few more right here, Vinny, great questions, because let's do more difficult ones. Be careful. Just say, Brian, that's a what by what. MG, great job putting the formulas in the chat. Rows minus 1 times columns minus 1. Brian, that's a what by what. We're going to do 2 more to practice and know how to do chi-squared degrees of freedom like this. I can't promise you, Avery, that the jump out will do it. Brian, that's a what by what. Brian, that's a 2 by 5. Does everyone see the 2 by 5? Brian, that's a 2 by 5. So the degrees of freedom are 1 times 4. You just subtract. 2 by 5, drop each one, 1 times 4. Great job, MG. I'm throwing 1,000 point. MG is putting those formulas as we would put them if we're solving them on a sheet of paper. I was like showing the visual and showing the quick way for the chi-squared to do it. And Carson, great work right there too. So much great work, everybody practicing right here. Let's do a more difficult one with a lot more groups. I might have to actually make the output if we don't have it. Oh, no, we got one right here. Be careful. This is a bigger one. Okay, Brian, that's a what by what. Brian, that's a what by what. So first look at it and be like, okay, Brian, that's a what by what. And then I'm going to do a trick one next. Brian, that's a what by what. That's a 5 by 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. It's a 5 by 4. So 5 by 4, drop each one, 4 times 3. Does everyone see that? Just 5 by 4, 4 times 3, and 12 degrees of freedom. Now I'm going to try to trick you. I'm going to do something. People probably know if you've been watching us practice how to do degrees of freedom for this. You probably know what trick's coming right here. Okay, so trying to make it so you can't see it. 2 seconds. Okay. Oh, darn it. Well, let's do this. I'm trying to trick you, remember? Really? What's going on? There we go. Okay. Be careful. Get ready for it. People already... Yeah, Leo knows where we're going with this. How many degrees of freedom for this? How many degrees of freedom? Be careful. This is where usually an error is made. I just want you to answer how many degrees of freedom there are. Great job. Tessa right there helping out. And everyone's saying 1 degree of freedom. Another 1,000 points. Great job. And so many people right there knowing this is 1 degree of freedom. The common error when you get this is to use the totals. When we say something is a 2 by 2, what we're saying is that there's 2 answers here. So that's 2. And there's 2 answers here. The totals are not part of the answers. Like the totals are just the sums of the columns. There's 2 answers to each question. So this is a 2 by 2. Since it's a 2 by 2, I know I can't trick you right here. It's a 2 by 2, 1 times 1, and there's 1 degree of freedom. Great job right there. Everyone gets it, and keep up the great work. You know the tricks, and you can't be tricked on this. You got it. Excellent job. Who's in the lead on the Kahoot? We did so much practice right there, and that was such great work. There we go. Leaderboard's locked up. Next question. Here we go. What is the null hypothesis for this test? Ooh. Now remember, the chi-square test of independence does not use... correct, Carson. I'll send out an email reminder because this is our last major stream. So I'll send out an email reminder. So the chi-square test of independence, there's a quick and easy way. We just put what word between these things. The null hypothesis for the chi-square does not use statistical notation. We just put what word for the chi-squared test of independence, which is 2 categorical variables. You just say independent. Try to form a sentence with gender-independent broken bone. Gender-independent broken bone. Now, you see means here. That's for quantitative data. Nothing about this is quantitative, so that would just be wrong right there. So the null hypothesis, we got a lot of answers coming in. Thank you so much. Everyone's playing along and answering as we go, because I've kind of said it. Gender-independent broken bone, well, that's the null hypothesis. And actually, what's interesting, and I might be giving away later answers, what do you do to that null hypothesis? Looking at this output. No worries, MG. What do you do to that null hypothesis here? Your null hypothesis is that gender is independent of breaking a bone. What do you do to that null hypothesis? You're going to reject it. The p-value here is low. You're going to reject the null. Who looks more likely to break a bone right here? If you had to say to me, it looks like, if you look at male, female right here, who looks more likely to break a bone? This is data from students right here. Who looks more likely to break a bone? Males right here. Males have a bigger yes percentage right there. Males looked more likely to break the bone, and the null hypothesis being that gender is independent of breaking a bone. We definitely would reject it and say there's evidence that they're not independent. What do we mean by not independent? Well, the association looks to be that males have a higher probability of breaking a bone. Look how there's more blue right here within the male, less blue within the female. That shows us that males kind of a higher probability of breaking a bone. P-value is low, the null must go. Gotta go. Good stuff right there. I like it. Nice job, Luke. 2-answer streak. 100 points there, Luke. Great job. Ubot, you want to do a question? You wanna help us out?
Oh, where am I? One more try. Thank you, Brian. I will do the next question. Mubot announcing leaderboard. Decisive Goose, great job. Let's do this. Mighty Godzilla. Is that Godzilla? I think. Gazelle. Let's do this. Question 10. Multi-select. Woo! What is the alternative for this test? Why is that a multi-select, Brian? I have to go. Is this a multi-select?
Let's find out. Gender, the alternative. Okay, it's probably not a multi-select. What have I done to this question? Oh no. Okay. Ooh, I think it is a multi-select. Ooh. Sometimes I update stuff and I forget. Okay, so the easiest way to think about the alternative. Pass Brian, I like what you did here, I think. Because the alternative in the easiest sense is to say what? The alternative in the easiest sense of the talking about it is to say that the two are what? The alternative in the easiest sense is to say that the two are not independent. But if you say that they are not independent, you're also saying, in other words, that they are associated. What could you also, instead of saying associated, what's another word that could go right here for 1,000 points? What is another word instead of associated? We could say gender is what of breaking a bone. They're what on each other. Instead of saying associated, what's another word that could go right there? Instead of saying gender is associated, dependent. Dependent or related to some word that tells us they are associated. Oh no, Avery. It should be both those. We're going to cross our fingers. Should be both those. Yep, they are. Those are both. So we had less people saying the associated. Just knowing that those are synonymous right there. Kind of, this is some good practice right there. How do I find the p-value? Well, we're not going to find those definitely by hand on the test. It would be this value right here. Carson, good question. There's your p-value right there, the 0.0001, which means we're going to reject the null. Oh, partial credit. Nice. Yeah. I love it. That's all right. We got half right. It's going to be an interesting shakeup on the leaderboard, I think. You, wow, Decisive Goose and Epic Hen and Mighty Godzilla, you shall be called now. Knowing Squid and Dandy Dove. I like Dandy Dove. Let's continue on to the next question. Here we go. Find the missing value. Is it a p-value? Let's find out. It's an expected cell count with tons of time. Tons of time to pull out your calculator to see if you know how to find expected cell counts. Many questions on the test sometimes blank out a value, especially with the chi-square test of independence, to see if you can find a missing value. So we've got, are you born in Tennessee by your gender? So what would we do right here? I'm going to start solving it at 50 seconds. So at 50 seconds, you're going to see me start drawing on it. The formula is row total times column total over grand total. Row total times column total over grand total. This is on your formula sheet. 8 more seconds till I start solving it on the screen. Okay, it's time for Brian to start the solve on the question. We're going to take our contingency table. Remember, the formula is, trying to not block the answers here. The formula is row total times column total over grand total. Always draw it out if you can, which is row total times column total over grand total. Notice how it zeroes in on that cell, as in this cell, we've kind of created a bullseye on it. So we're just literally going to plug into the calculator the row total of 421 times the column total of 479 divided by 770. And notice how it says we're looking for the expected That's because all of these values here for the second thing are the expected values. And it's 261.89. There it is right there. Good work and good practice. That's how we do it. Oh, I am Mighty Godzilla now. They do evolve right there, Troy. You went through. You used a what is it? Some sort of evolution stone in Pokemon Go. Congratulations. Do the multiplication first and then divide by. The music makes me feel like I gotta know this answer. Pretty epic music right there, Kahoot. We got Mighty Godzilla third in place still. Epic Hen, Decisive Goose, great work. Please remember this, even if you're not winning the Kahoot, keep playing. We're just here to practice. Watch the solves, write them down. Even if you're not winning, this is good practice. So let's continue on to the next question. Here we go. That background is moving, isn't it? Okay, next question. Find the missing value. I'll start solving here at 50 seconds in again. This time you're doing a cell chi-squared. Time you're doing a cell chi-squared. So the cell chi-squared is the formula observed minus expected. Someone might be saying to us, wait, I don't see any observed in this output. Where are the observed? These are people's gender, and if they're born in Tennessee, where are people's observed? Observed are the what, which is the name of the condition that leads to this kind of data. In this output, the observed are the whats. The observed are the whats. We're almost to Brian solving it. The observed are... I'm going to solve it 40 seconds. Not a lot of people have answered yet. The counts. The observed are the counts. So to solve this, we need to take right here and go observed minus expected squared over expected. So we're going to take the observed, because we're looking for a cell chi-squared, which is this value here. Observed minus expected, we take the difference and we square it over expected. So the observed is what we observe right here, and the expected is this. So that's that value right there. Observed minus I'm gonna run out of time. Observed minus expected squared divided by expected. And there's the answer right there on the buzzer. On the buzzer, 128 minus 131.895. So there we have to take the observed minus the expected, square the difference, chi-squared, hence squared, then divide by the expected, which is 181.895, and there it is right there. Observed minus expected squared over expecteds are cell chi-squareds. From here, how do we find the chi-squared test statistic? That's a cell chi-squared. How do we find the big chi-squared test statistic? How do we find the big chi-squared test statistic? What's up, Carson? How do we find... Could Jane Carson expand good question, Jane Carson, right there. Can you expand? We sum these up right here. So that's the sum of all the cell chi-squareds. So the sum of all the cell chi-squareds, sum of all the cells, is the chi-squared test statistic known as the Pearson. That's in the output when you see the Pearson chi-squared test statistic. It's the sum of all the cell chi-squareds. The cell chi-squareds, here, let me highlight these real quick right here. Heard some noises. The cell chi-squareds are the observed minus expected squared over expected. And the expecteds are obtained from the row total times the column total. We did one of those a second ago over the grand total. And the counts are literally how many you see in each group. So the count would be how many we see in each group. And then they go in that order right there. Like, this is the count for this. Thank you so much. I see people are answering and helping out. This is the cell chi-squared for this one. And this is the expected for that one right there. So those are the values. No worries. And then make sure to divide by the expected right there, Kristen. So great work. Not that many answers. That's all right. Remember, try reviewing this and practicing just with output. The formula is on the formula sheet. Make sure to check out our videos that we've been doing lately, Benjamin and everyone, because we worked through it and we went through everything on the formula sheet, showing how to solve each thing. And that was done yesterday. So check out yesterday's video. Who's on the leaderboard? Knowing Squid's on the leaderboard. So is Epic Hen. Decisive Goose is running away with it. Let's find out who's going to win. Here we go. What are the degrees of freedom for the one sample t interval? What are the degrees of freedom? I should have put it's too complicated. Well, but that's not the answer. This is not the answer. It's the one sample T. The one sample T. What is the one sample T? How do we find it? Nice and easy formula. Who can drop that formula in the chat? The one sample T interval has degrees of freedom what? The one sample T interval has degrees of freedom what? N minus 1. So what's the sample size? 770. What's minus 1? 769. The way to remember it's too complicated is for the 2 sample T. The 2 sample T is a too complicated formula. Once again, we just do not solve it. It's the one we use the degrees of freedom calculator on. So we'll just see that the 2 sample T has a too complicated formula. Why do I say it's too complicated? I will literally show you 2 sample T degrees of freedom formula. It is a too complicated formula, which I'm not going to sit around and solve. And I doubt you're going to sit around and solve either. 2 seconds right here as I bring it up on the screen. Here's the 2 sample T degrees of freedom formula. You're not going to solve that, nor am I. We're going to go over here and enter in the values, and it's going to solve it out for us for the degrees of freedom, which tells us the shape of the T. So we use an applet just to solve it, or in jump output for the 2 sample T, it'd be given to you right here for the degrees of freedom. So once again, we're not going to solve the degrees of freedom for the 2 sample T. It'd be given to you. No worries, Laura. Just here to practice. This is the 2 sample T degrees of freedom, a too complicated formula that we do not solve. And the 1 sample T is just N minus 1. Awesome work. Who's on the leaderboard? It's locked up right now with Decisive Goose, Knowing Squid, and Epic Hen. Mighty Godzilla is going to come back, though. Next question. Here we go. What is the missing p-value? I love these questions. What is the missing p-value? Now, there's a quick concept. I give a lot of time right here. Now, it is rounded. You have to round it up. So, what is the missing p-value? What do you know about the greater than and less than p-value? What do you know about the greater than and less than? Because the greater than shades above the line, and the less than shades below the line. So think about this. You're going to go all the way above and all the way below. That shades 100% of the curve. So I'd start looking at these immediately and being like, which of these could add up to 1? They're complements of each other. Great answers right there, Kristen, everyone. They're complements. So they're complements of each other. So which of these adds up to 1 is the question. If you take it and add up to 1, which of these adds up to 1? The one that adds up to 1, just, you can do the math right here. You might say, wait a minute, it doesn't. Well, you round it and it does. Oops, wrong thing. We could take right here and go 1 minus. Say that's not. The reason being is also we could take what of this one? What's another way to solve it right here? Take what of this value? The greater than and less than are complements. There you go. Here's the answer. Take half of the does not equals, because the smaller one, if you double it, is the does not equals. So not square rooted. Take half of it. Take half of it. Pretty right there. Take half of it. Because the way these work, and we'll just do a quick visualization. The way the p-values work is if you have one of them, you can actually solve all of them. So we're just going to take and copy this curve down so we can actually make curves that look identical today. And got to work smarter, not harder. If you land all the way over here on the curve, the greater than p-value, let's just say hypothetically, is 0.08. And then this, I think this will help explain it. The greater than p-value is 0.08. So we're saying that 8% of the curve is shaded here. What is the less than p-value? So just theoretically, what does the less than p-value have to be? So who knows the less than p-value going off the theory right here? The less than p-value is going to be what? It's going to be 0.92 exactly. And this one does say in the jump output, I do want to show the next one right here. Well, let's write the number 0.92 because that adds up to 1. Those have to sum to 1. So those sum to 1 right here. But then we do have to know that in the jump output, it does say greater than absolute value t. I do want to point that out, which is your does not equals test. This is the does not equals test. It says greater than absolute value. It's the first one on the output. And for that one, what do we do to the smaller of the two? So for this one right here, what do we do to the smaller of the two? So there's the p-value for the first. There's the p-value for the second. For this one, what do? We double it, right? And if you look visually speaking right here, we have doubled the smaller of the two. And that is the first one in the jump output. You do see it on the screen here as the first one in this output, the greater than absolute value t, which is a does not equals, which will shade both signs. And there's the less than, there's the greater than. Those have to add up to 1. So less than, greater than, p for probability right there. Hopefully that helps you understand a little bit more of the concepts. Going on to the next question. Leaderboard shakeup. Oh my gosh. Next question. Here we go. Find the missing p-value. What is the missing p-value? What is the missing p-value? So it should be nice and quick. You just do what to get it? Avery says, I get it now. Avery's like, I got this. What do you do to find the missing p-value here? Do what? If you have the two, the less than, the greater one, which add up to 1, we can see that visually speaking right here. You take it and you what it? You just double the smallest. Just take it and double the smallest. You say, okay, well, less than and greater than add up to 1. Those are the less than, the greater than. They add up to 1. We'll just say that more times. We've got 26 seconds to talk this over. And we just take this and we double it. So you should be able to figure out the answer from the choices given below on what the p-values be. Oh, no. No! The missing p-values right here. These are p-values. No, Avery, no. Great job, Alistair, right there. And good practice, everybody. I got 50 people practicing and playing along right here. Okay. And looks like, how'd we do? How'd we do? Good work. That is the missing p-value. And we showed how to do it. Let's find the leaderboard. Still Decisive Goose running away with it. Let's find out who's going to win with a few more questions. What is the missing t-ratio? Now, the t-ratio right here is the difference standardized. You can actually quickly solve this in your head, theoretically, super quickly. If you look at the answers given, theoretically, it has to be certain answers. The numbers here have a specific kind of ratio to them that I picked for this problem. First off, the t-ratio is going to have to be what? You can actually see where it's on the curve. You could deduce instantaneously that the t-ratio has to be what? Narrowing down your answers pretty quickly. The t-ratio has to be what? Because you can see where the t landed. Negative, correct. Has to be negative. The t-ratio has to be negative. If the t-ratio is negative. Does that make sense? So now that we know the t-ratio is negative, we just know it's the difference divided by the standard error. Notice how this is 0.23, negative 0.23, and this is 0.023. It's almost like they have a what-to-what ratio. It's almost like, just deducing this, we're going to show it mathematically here how to get in a moment. It's almost like they have a what-to-what ratio right now. Just look at them, like this is 0.23 and this is 0.023. It's almost like they have a what-to-what ratio. Remember, it has to be negative, so you could deduce the answer pretty quickly on this by the ratio of these two numbers. A 10 to 1, exactly right there, Kristen. So that kind of narrows it down. It has to be negative in about a 10 to 1 ratio. So it's either a 10 to 1 to 1 to 10, either which way. We're going to show how to get this mathematically in 3 seconds. The answer is red right there. So let's show how to get that. The t-ratio on the 2-sample t-test is the difference standardized. So let's go over here to a Word document. And we need to show how to get this because the difference is the formula what? What is this formula to solve for the difference? To solve for the difference, what is the formula when we do the 2-sample t-test? There's the formula for the 2-sample t-test. So what is the difference? That is the 2-sample t-test formula, which can be found on the formula sheet. The standard error, the difference is the formula more explicitly. S sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. And so the difference is the sample difference. So that is the difference. The standard error is the standard error. So how could you solve this right here? How could you solve the t-ratio right here since you don't have it? You want to solve this number right there. How could you solve the t-ratio? How can you get it? Just show the math in the chat right here. How can you get it right now mathematically? We've got the numbers highlighted. Divide them. That's just it. Just divide those numbers. If you divide those numbers right here, you will get the t-ratio. So we want 0.23016 and then divide by 0.02318, and there's the T ratio right there. Just divide the numbers, carry the decimals with you as you go, and great work right there. And that will be the T ratio, negative 9.9292. And that is our T ratio right there, rounds up to that. Good work and good practice. Here we go. Leaderboard's still locked. Next question. You never know. It could change instantaneously. Remember, we're here to practice. What is the missing value of difference? Now, this one's a little bit more difficult. Now, when you think about this, you could reverse engineer it. We've done stuff like this on the test, hence why I do it. I don't love leaving out things like this that we usually don't solve for. We don't usually solve for the difference. Now, this is the difference in GPAs. So this difference we saw previously was negative. That's the answer. This one right here, we'd have to reverse engineer solve using the equations. We'll see it in a moment. But what does this tell you since the difference is negative? Who did we observe having a higher sample mean GPA? Since the difference is negative, what does that tell you about this difference in GPAs? Which of them was higher? Since the difference is negative, what would it be? It is, Kristen. These formulas are all on this sheet. That is correct, Jake. Since the difference is... No, boys are not stupid. It's me. It's my fault. I did not help our GPAs, gentlemen, so blame Brian. Don't blame Canada. Blame Brian. So if you look right here, it's the same formula as we have on the previous sheet. And so let's go check out the formula we have right here. What you'll notice is this formula could be written as difference equals, or difference over standard error equals T. So if we don't have the difference, we'd have to take right here and multiply the standard error. Does everyone understand right here? If you multiply both sides by the standard error, T times standard error equals difference. All we're doing is just multiplying both sides by this, which would eliminate it on this side, and it'd be on the other side. So we're just finding the difference by doing that. So just mathematically, if you do the T, which we have now, times the standard error, that would be the answer. Just mathematically multiplying both sides by the standard error is going to, so we could write standard error right here. That's going to cancel out that standard error. That is the standard error. So T times standard error, but these two cancel on this side. Not a huge fan of this question, but you never know what we could leave out, just understanding conceptually. So let's take the T times the standard error. So there's the T times it by the standard error. I actually had to think over that one and write it out to do it because I don't usually solve for that. Hence why we love this chat too. Good song right there, Summertime Sadness. Good work. It's probably more important to know what the difference is that we saw in our sample that females had higher GPAs than males. That's a little bit more important, I'd say. Like that question, don't love it. I wrote it, so what are you doing, Brian? Next question. Here we go. Better question, I'm sure. What is the null hypothesis for this test? Pretty easy if you know how to do null hypotheses. I should have probably done 30 seconds on this one. Pretty easy if you know how to do the null hypothesis. What is something we always know about the null hypothesis? You can easily scan these over, and you need to know this about the null. Kristen said, totally got that first. And why'd you get it? Kristen was like, boom! Always has the equal sign. If you're thinking null hypothesis, you say it has to have the equal sign. Now, when is the only time we don't use statistical notation? I hope so too, Leo, but we're here to practice. Don't worry. If you get this wrong, you're here to practice, and that's good. If you got it wrong, you're in the right spot. If you got it right, we're wasting your time. What is the only time? We're not really wasting your time. What is the only time we don't use statistical notation? The chi-square test of independence. The chi-square test of independence is when we say this is independent of this. That's the only time we don't use statistical notation. No worries, Brent. Great work, Brent. 100 points. Remember, this is to help us to get better and quicker at being like, the null has the equal sign. The null has the equal sign. And there could be some misclicks, or if you got this wrong, we're here to help you practice. So anytime you see a null hypothesis in statistical notation, the null has the equal sign. And you should just go right to the one that has equal sign and say that is the properly written null. We do have the less than, which is a one-sided, the greater than, which is a one-sided, and the does not equals, which is a two-sided. And these are all two sample T's because you have two means you're testing. And don't worry, 100%, I'll take it. That's good enough. That's good enough. We're here to practice. The null has the equal sign. I'm throwing 1,000 points. Don't worry if you got it wrong. You were here to practice, and hopefully you learned the null has the equal sign. More people getting it wrong is better. More practice. but try to get it right. Next question. Leaderboard shakeup. Bold Squid jumped into the lead with that. Bold Squid, this is super close. Decisive Goofs might fall off. You never know. Next question is, what is the alternative hypothesis for the two-sided test? So we just mentioned it previously. Bro, overthinking killed me on the last exam. Nowhere over the central limit theorem. Oh yeah, that one. That one's ridiculous. That was part of the curve on the yeah, that one. That one's ridiculous right there, Avery. That one was reason for the curve, which you never know. While sometimes we have a curve, sometimes we don't. So we're talking about the sidedness of a test. Sidedness could be done for pretty much any test. The only test that doesn't use sidedness is chi-square. It's a theory question that's never been on the exam. But you can do a greater than test, a less than test. And the greater than test and less than test, you're welcome, Brent or Benjamin. The greater than test shades to the right. It shades how many sides of the curve. If you shade to the right of something, how many sides of the curve are you shading? If you shade to the right, you're shading how many sides of the curve. Like if we say, let's see if it's greater than this. If you shade to the right, you're shading one side. If you shade to the left, you're shading one side. But if you shade the does not equals shades both sides of the curve. So the does not equals shades the right and the left side of the curve. And we'll see this here in a moment with what we did in the output. But the does not equals is called the two-sided because it shades both sides. That doesn't have anything to do with the two-sample t. There could be, you never know. We figure it out afterwards. There could be. It's possible. I don't want to say will or will not happen because then I don't want to be bound to those words because I do not know the answer. Thus, I will say it's possible. I do not know the answer. So if you notice right here, the one-sideds are the less than and the greater than. The two-sided is the does not equals, which shades both sides. Hence, we call it the two-sided. It can be for a two-sample t test, but it doesn't have to be. How do we figure out which way of the curve to shade? I'm almost 50-50 on it, Luke, in truth. I don't want to say either way. Like I think it'll happen or I don't think it'll happen. I really don't know. It could be for a two-sample t, but it could be for a one-sample t or a one proportion. The idea of one proportion, 1t, 2t goes with the variables you're using. The researcher chooses the sidedness. The researcher says, I want to see if the proportion of in-state students is more than 60%. Is that a one-sided or a two-sided test? The researcher says, I want to see... Oops. Really? Oh, I know what I'm doing. I want to see if the proportion of students in state is over 60%. That is a one-sided, one proportion test. So one-sided, one proportion test. I want to see if exam 3 scores are lower than exam 2 scores. What is this? I want to see if exam 3 scores are lower than exam 2 scores. What is this? I want to see, so it's a what-sided, what kind of test? I want to see, it's a one-sided, and then what is it? What kind of test is this? I want to compare is it one sample t-test? I have two samples. It's a one-sided two-sample t-test. Does that make sense? It's a one-sided two-sample t-test. I want to see if exam 3 scores are equal to 80 this year. So what is this right here? I want to see if exam 3 scores are equal to 80 this year. I want to see if exam 3 scores are equal to 80. So you have to ask like what kind of variable. It's two-sided. Because we're testing is it equal or not equal. I didn't give a direction. Two-sided, one sample t. Because we're testing one mean. Does that make sense? By Monday, hopefully at the latest. Like they have until Monday. They're supposed to. A lot are getting released, but they have been told they need to be graded by Monday, like by Monday night. So that's what they've been told. And I'm going to be telling them, hey, make sure they're graded. I might send out a reminder today. I will. Like now that I'm thinking about it. They've got their test too. Huge shout outs to the graders. They're working super hard, but they're supposed to be graded by Monday. That's what they're supposed to. That's what they've been told. They've been pretty good all semester, so shout outs. Great work. Does this make more sense? Who feels like they understand this a little bit better? Just like we want to see which project took longer to grade. Or is there a difference? We want to see if there is a difference in time taken to grade project 1 or 2. So what would this be right here? We look at how long it takes for the projects to be graded. What is this? We want to see if there's a difference in time taken to grade project 1 or 2. Just bringing it to our real world stuff right here. This is a two-sided because we want to see if there's a difference, and two-sample t-test, or two-sample t-interval, or two-sample t-test. Well, we could do the interval, which is basically a two-sided. It's a two-sided, two-sample t-test. How long did it take on average for project 1? How long did it take on average for project 2? And then we're looking to see if there's a difference right there, and the difference denotes the two-sided. Notice how the lower right here is going to be indication of the one-sided, and over right here is indication of the one-sided. The researcher decides this. Words like are they equal to are going to denote things like two-sided, which is when we would denote here just trying to see if there's a difference, which would be the does not equals test. So these are like the key words we'd have to see right here. And then the other words like between project 1 and project 2 are comparing two means. Looking at, let's put this right here. I want to make it clear which ones go with which. But there's the answers below the question. Don't mix up. The answers are below. So good stuff right there. Just a little bit of practice on which tests go with what, and the good stuff. My grade was on it. I got my grade a week ago. Yeah. Grades should be coming in. Make sure you get your extra credit. And if you have questions about them, please let me know. I've already regraded a few projects. Please, please, please let me know. It's your grade. You get to give questions. Next question. Here we go. Leaderboard's locked up. Here we go. Interpret the difference. Ooh, is it the same difference I already interpreted? I already interpreted this for you. So if you're listening in, what is this? This is the two-sample t-test. So what do you know is a word you should be seeing right here. On the two-sample t-test, you should not use this word. You should use this word. What word should you be using for the two-sample t-test? The two-sample t-test compares what's? Oh no, Kristen. Seeing right there that we see right there, we're comparing means. The two-sample t-test compares means. So we're comparing means. No worries. Two-sample t-test compares means. So don't use proportions in your interpretations when you're dealing with the t-tests. Don't mention proportions because Mr. T is mean. So right here, the females, whatever we're comparing, I think this is like pets or something. The mean for females is this much lower than the mean for males. There we go right there. Because the difference is negative. So the difference, wait, the mean, wait. Oh my gosh, wow. I was saying it earlier. Oh my gosh, Brian got one wrong. Well, I'm glad I said that there at the very end. The difference is negative, and just think about it mathematically. That's oh my gosh. My brain overheated, everybody. Think about how the equation worked. Brian lied. That is correct. Because when you think about this mathematically, if you think about male minus female, and I tell you this equation equals up to -2, plug in numbers right here to fake solve it out. If I have male minus female equals -2, just plug in fake numbers. Like tell me an equation that would solve for this, and then look at how the numbers are. 2 minus 4, exactly. So just plug in fake numbers, and you will see that the female number has to be higher. So just thinking about it theoretically, not 8 and -10 though, because the difference here has to be -2. So this solves out to -2. Does that make sense right there? Everyone, good practice. I did get that one wrong, and I wrote the Kahoot. So I'm glad that the answer is right in the Kahoot. But Brian looked a little too quickly, and the negative number means the second one is higher. And we were saying that earlier. So my brain was saying, wait a minute, there was a little alarm going off. Exactly. 8, well, it's 8. Oh, you're saying 8 minus 10. I thought it's 8 minus 10 is going to be that, but 8 minus -10 would not be that. Does that make sense? So the first one right here could be 8. And the second one could be 10, and we're subtracting their difference right there. Oh no, Kristen, I said it at the very end right there. Every time, maybe some people click that at the end right there. But right there, it has to be means, and this is quantitative right here. So let's find out. Oh my gosh, the leaderboard shook up. Brian had me question them numbers. Next question, here we go. Story time, what is the type 1 error? The null hypothesis is it's a twig. Okay, so you're walking through the woods as you normally do, and you're looking around, you're saying, you know what? I think all these things are twigs, because most things are twigs. But you know what? It could be a snake. Now remember, the null hypothesis is that it's a twig. So I want you to think in a type 1 error, we were practicing this earlier, the null is what? In a type 1 error, the null is what? Someone put it in the chat. In a type 1 error, the null is what? In a type 1 error, the null is what? The null is what? In a type 1 error, the null is true. But we're going to reject the null. So what you're saying right there, if you say the null is true, tell me about all these things on the screen right here. They are definitely what? Now, don't worry. If the null, they're not Turtwigs, they're not Pokemon. If the null is true, those are definitely what's for 100% certain. Not like we're guessing, not like we think they are this. They are twigs. So the null is true, those are twigs. So, with that in mind, what are you going to do to the null hypothesis in an error? I think they are. This goes back to my archaeology days where I was like walking over brush and someone said, don't walk over that. And I heard, shh. I made a type 2 error. I was like, everything's fine. And it wasn't. And I got out of there. Brian made a type 2 error because in a type 2 error, the null is false. And I failed to reject it. I was like, everything's fine. I'm not rejecting the null. I think they're all twigs. And I was like, oh, they're not. I'm getting out of here. In type 1 error, the null is true. So these are twigs. Back in my archaeology days, doing some CRM, cultural resource management. So the null is true. You think it's a snake, and it's not. You think it's a snake, but it's not. There it is. You think it's a snake, but it's not. Pretty. You see, we had a lot of people doing the type 2 right here. Be careful. We did a lot of reviews earlier, and that's almost a 50-50. Be careful. We'll have another story time here in a second. So if you got this one wrong, type 2 error means what? Everyone help us out here. Practice issue, right? We're going to the main screen. In a type 2 error. Good to see you here, Beatmaster. How'd you run? Yeah, it's crazy stories I got for you. Got my master's in business analytics. That's how. Shouts to MSBA program here at UT. In a type 2 error, the null is what? And Alexa's practicing right there. In a type 2 error, the null is false, and we failed to reject it. In a type 2 error, the null is false, and you fail to reject it. Now, with that practice right here, we did a lot of practice earlier. We were practicing this earlier. I'm trying to find the screen, but check out the earlier practice we did right here. That was power and stuff. But we were practicing this earlier with type 1, type 2 error. We talked about what an error is, and then we did multiple practice. So check out the earlier portion of this video if you want to go over what is type 1, type 2 error. We did a whole 27-minute practice, and we did quizzes on it. So right there, Lorigan, 100 points for the chat. In a type 2 error, the null is false, and we failed to reject it. And then we tried to slow down and talk about what it meant and what it would mean in this context, and we did 4 of them. So check out the earlier portion of the video if you want to practice those and see if you get the right answers and you understand how to do type 1, type 2 error. So good practice in the chat. The 2 F's of the type 2, the null is false, and you fail to reject it. So speaking of, let's go to the leaderboard and maybe do another storytime question. Epic Hen, great job. Mystery Pony, Knowing Squid, and Bald Squid, all the squids on the leaderboard. And Decisive Goose, great job. Here we go. Next one. Storytime, what is a type 2 error? The null hypothesis is that the tree is healthy. So the null is the tree is healthy. In a type 2, you're going to look at that null hypothesis and tell me it's what? In the type 2 error, remember the type 2? We were just talking about it a moment ago. You're going to look at the null and tell me that's what? You always look to the null when you talk about this. In a type 2, you're going to look to the null and tell me that's what? Type 2, someone's like, what is he doing right there? You're going to look to the null and tell me it's what? The null is false. We're making a statement about the world. It is false that the tree is healthy. So I want you to tell me reality in the chat right now. So tell me the reality. The null is false. So what does that mean to say the null is false? You're saying The null, which is the tree is healthy, is a false statement about the world. That is just not true. So what is this? Kristen's getting all the Coca-Colas. The null is false. So tell me about the world and the way the world is. Somehow we know this. Claire said it perfectly. The tree is not healthy. That is reality. You know reality. Avery's getting the theme of the house and the picture. So this right here, the null hypothesis is false. It is false that the tree is healthy. That is a statement about the world. And thus, since the tree is not healthy, the tree is dying. You can see it here in the picture. But what are we going to do? Because we're going to make an error. We're going to make an error. Are we going to cut down the tree? We should cut down the tree, right? The tree is dying. The null is false. The tree is dying. So that house failed to reject the null. No, that house accepted the null hypothesis. It made a lot of errors. I like that right there. Trevor grabbing that as a quote. So in this example right here, quote 218 now from Avery. Oh my gosh, scary. We are going to fail to reject the null. We are going to leave the tree up, and the tree will fall because the tree is sick. There it is right there. Great work, and we're getting on track now with some right answers. Love it. But does that make sense? We left the tree up because we failed to reject the null. I know, right? You just got a lot of great quotes, Troy. Sorry about that, Troy. Yep. So we failed to reject the null, which means we left it up, and the tree fell because the null is false. The tree is not healthy. So great right there. If you do some Marvel stuff or something, or a good stats pun, that's a good way to probably get a quote. We might go like a few days without quotes because I forget to add them, but I try to, or especially someone's like, that should be a quote, as long as it's like something fun. I'm usually good if people are like, make that a quote. People have said that before, like, oh, that should be a quote. Let's find out who's going to win right here. A few more questions. When doing a two-sample T, the variables will be what? Did they carry Tiny Brian in your purse? Did we make that a quote? Can't wait to get my fried rice in this and then stay for 13. Ooh, fried rice sounds good. It's pork fried rice or regular fried rice? Oh, you're making me want to make some like fried rice and teriyaki sauce. Mr. T is what? He's mean. He's quantitative if you're doing drugs. So the two-sample T, and we have a lot of good review stuff on here. Like if both variables are categorical, this is not the answer. We'd be doing the what? Both variables categorical, which means we have count data. What would we be doing right here? Both variables categorical, we'd be doing the what? Both variables categorical, we'd be doing the chi-squared test of independence, count data. We don't use identifiers, so that can be eliminated right here. We don't use identifiers. And both quantitative variables, which is not the answer, would be what? Two quantitative variables. Q, straight enough, no outliers. Two quantitative variables would be what? Who can answer in the chat? What is two quantitative variables? The answer is red. Two quantitative variables would be what? Which a lot of people answered. Two quantitative variables is what? You can analyze it with a line, and you could talk about the linear relationship or the linear this. So we could do scatter plots, which are the visualization. Great job, Avery, right there, which is regression or correlation. Two quantitative variables is regression or correlation. Think about this. If you have two means, you're going to have two categories, and you're going to analyze the quantitative relationship. So QQ is two quantitative variables. That's regression or correlation. Categorical is chi-squared, and then we don't use identifiers, so that's just way off track right there. Check out the tools and techniques portions of our videos where we go over these a little bit more in depth. Next question. Here we go. Leaderboard locked up. Good to see you here, Georgia. And next question. Here we, clicking adding mods, making sure we got mods in. Next question, here we go. And you might have two accounts. Sometimes people have two accounts. Make sure to check. You might have a second account, so make sure you're on the account with the points. I can also check if anyone's running their points. I can check them too. But if you have two accounts, maybe you might check, see if you have two accounts. When working with statistical power, which of the following do we have the most control over? The absolute most control over. Now think of this, the absolute most control over. The absolute. That you can just change like that. You could be like, let me change and do my points and let me just see. Let me just figure this out. Change my this level. So what can we just instantaneously change like that at a moment's notice? You're like, you know what? Just gonna change it. I love people are already saying in the chat. This is whatever you want it to be. So the answers on here, effect size, and check out the earlier portions in the video. Effect size is going to be the difference between the null and the truth. We have absolutely no control over this. In our examples earlier today, we were talking about Dr. Acula, jokes, and we have no control over the effect size of how sick someone is. Beta is the probability of a type 2 error. Alpha is the probability of a type 1 error. Sample size is how much data we collect. So I mean sample size too, because on projects we take we do that, but the researcher, sample size is one you have some control over. Which do we have the most control over, though, would be alpha, because that can change just on researcher's preference. Alpha could be changed at any moment, but if you go out and collect data, you are kind of limited to how you collected your data. And so right here, I did put sample size 2. You do control sample size. You don't control effect size, and beta is found. Do you have the ability to change alpha at any point during the study? You do. It's not advised, but you can change alpha at any point. It's not advised. What do we usually use as alpha? What do we assume is our type 1 error rate when we reject the null? What is our type 1 error rate when we reject the null? For most purposes, 0.05. 0.05 is our usual type 1 error rate when we usually reject the null hypothesis. So that is our usual. Beta, why is it important to know beta? It's your type 2 error rate, and beta can also be used to help us find what? Beta can also be used to help us find what? What can we use to help us? Why do we need to know beta? Why is beta also important? Because 1 minus beta is what? And we went over this earlier. These are the examples where we talked about power. 1 minus beta is what? Is power. So beta is type 2, and increasing sample size decreases beta. We can kind of control that, like might be limited by what we do for our study. Effect size right here, which we talked about earlier. And then we have here our alpha, which is our type 1 error rate, will decrease type 2 error rate. Alpha and beta are not complements, but they are inversely related right here. So make sure to review this right here. We don't really control effect size. We do control sample size, and we have super control over alpha, but it's not advised. Dr. Mike doing great work right there. It's not advised to really change alpha that much because you'll increase your type 1 error rate. You could maybe lower it to be more particular and not create type 1 errors. It's a pretty B. Oh, thank you. It's because of the way I sound my name, my cursive B's. Appreciate that. Thank you, Laura. Next question. Here we go. 2 more questions to go. Calculating degrees of freedom to test the freshman, sophomore, junior, senior versus owning a bunny, which everyone should own a bunny. They're amazing animals. So how would we get degrees of freedom for this? Should be nice and quick right here. I did. I'm trying to think. Yeah, that's your guy, right, Leo? He did super great. That was a really good fight last night. That was one of the top ones, I'd say. His footwork and his arm work, like you just see him being like, it was talking about the creator clash last night. That was one of the top fights. Harley of Epic Mealtime definitely showed that he's got a huge heart. Like watching him fight Ego Raptor was definitely, he showed like huge heart in that fight. And then even though iDubbbz lost, man, I'll tell you, you take that many punches from someone, you've definitely shown you've had a good fight, because that was a going the distance right there. I mean, that's not everyone went the distance though. Some people were down in 22 seconds. So, but it was very, very interesting, and Justin Mink's doing a great job too. So, Creator Clash, we didn't see it last night. A lot of fun stuff right there. I think I saw some of that. Was a long one too, right? I think I saw some of that one. That was a longer one. I think they went the distance too. They went the full time. It's a lot of fun. Check out some YouTube stuff. YouTubers battling it out. Avery, I'm sorry. Well, good thing you can just little pellets of it. Where did all our 50? I don't know. This one was an easy one, so we kind of just relaxed during it. How did you figure this out right here? How did you figure this out? How did you figure this out? How did you figure this out? There's 4 answers to your class level. There's 2 answers to having a bunny. So what'd you do? 4 answers to class level, 2 answers to bunny. And we could actually do some fake data here real quick, so stay tuned till the very end. We could literally go right here to bunny, and then we could go to class level. And we could do bunny, yes, 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 no. Oh, no, no, no. Yes, no, no, no. Could have just copy pasted. And then freshman, sophomore, junior, senior, and then go here, copy paste. And these are the yeses. this. That's going to be a real problem. And 80, 60, 40, 20. Okay, cool. And apparently everyone owns a bunny, my example. 2 seconds. We're going to make it look all pretty. Some value ordering. Freshman, sophomore, junior, senior. Apply, okay. Ordinal. Categorical variable by ordinal. Is your class level explaining you owning a bunny? Frequency, and there you go. There's the data. So who's way more likely to own a bunny right here? We're all owning a bunny. Highly suggest, do recommend. Who's super likely to own a bunny right here? Who's super likely? Who's super likely to own a bunny? That you own all those bunnies, Troy, right there. Seniors, the probability looks to be increasing. So what do you think the p-value? I can tell you right now the p-value for this, because this is a very strong relationship. Check out the videos where we go over chi-square test of independence. Does anyone have any guess of the p-value on this? This is super duper strong. I'm trying to tell you that this is very statistically significant. The p-value, I'm pretty sure down below, is basically going to be this. This is a higher level advanced theory question for you to be like, probably going to be close to this. Avery knows it right there. There's the p-value. Avery, how many zeros did you do, Avery? Avery pretty much got it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many zeros did Avery do? Avery, that's worth Avery almost got it to the amount of zeros. Avery, that's worth 1,000 points. Very close on the amount of zeros. Then the next digit is going to be a good guess. It's basically 0, and then a 1. Actually, wow, Avery, you were within very super close. Well, you did say very significant, right? So super small p-value. Good stuff right there. And as we see, this is a 4x2. 4x2. That was just a good random guess, I think, right there, Kristen. So lots of points. I don't know if I would have gotten it that close. I would just say it's about 0. This is just, for all intents and purposes, is about 0. If you're wondering when it would not be 0, this is another theory question we've done many times. So when would it not be 0? Well, look at really. So look at the following example right here. If we go and do the following, 2 seconds, redo auto recalc. So if you look at the following, now tell me it looks like someone owning a bunny, probably more real world data looks something like this. I'm just going to make it look like this, though. Now owning a bunny looks to be what of somebody's class at UT? Now owning a bunny looks to be very what of someone's class? Probably more like the real world data is going to look. Owning a bunny looks to be very what? Like just visually speaking. Owning a bunny looks to be, because for all intents and purposes, 89% of freshmen do not own a bunny. It looks to be very independent, right? And this is actually the most likely thing to see if the null is true. So what do you think the p-value is going to be? This is a little more advanced. We wouldn't have you solve it like this on the test. But since it looks super independent, which is the null, and it looks like the null says it should look, and it looks exactly like the null says it should look, the p-value should be what, theoretically? This is just a theory one. I'm doing a little higher level teaching to see if you would understand, like, since this is exactly what I expect to see given the null. Priya close, you got the right digits. But since this is the most likely thing to see given the null is true, the absolute most likely thing to see, p-value of 1. And then look at the chi-squareds right here, because think about this mathematically. Mathematically speaking, all the expecteds and the observeds are going to be what to each other? Every single expected and observed are what of each other? Every single expected and observed are what of each other? Every single expected and observed are all what of each other? Every single expected and observed are all what of each other? You can see it in the output now. Every expected and every observed are what of each other? They're all equal. So what are all the cell chi-squareds? The cell's chi-squareds is the observed minus expected squared. I don't think there's lightning around. There's one more question. We'll get to it in here. No, they're all equal. So all, and great question, Kristen, right there. All the cell chi-squareds are going to be what? All the cell chi-squareds will now be what? Because they're all equal. There's no differences. So no differences squared is 0. Oh, sorry. All the cell chi-squareds are going to be 0. And if all the cell chi-squareds are 0, oh no. Since all the cell chi-squareds are 0, what's the sum of all them? 0. And then the p-value here is 1. That's a little advanced theory right there. Just sometimes I teach a little higher level, but remember, just practice along. We did the test by hand yesterday, I believe, so check those out. Last question. Everyone get ready right here. This is the last question. You don't know. You could jump into the lead, but remember, we're here to review, to learn, and Tiny Brian's going to announce it as per usual. Remember to email me with you want an Amazon or you want a Starbucks. Let's check this out here with the last question. Here we go. Bold Squid, you could do it. Last question of the day. How could someone make this test more powerful? How could somebody, what option would they have? So what could they do to make the test more powerful? Why did I do 120 seconds? So there are 3 things that increase power. There are 3 things. What are the 3 things that increase power? Who can name the 3 things that increase power? What are the 3 things that increase power? Name them in the chat if you can right now. What are the 3 things that increase power? See if you know it. Put them on note card if you don't. The 3 things that increase power are sample size, alpha, and effect size. Great job, Laura, right there. Sample size, effect size, and alpha. And they are all inversely, like positively correlated with power. So this one right here is a little bit ridiculous because if you decrease the effect size, which you don't control, so you don't control effect size, but if it were to decrease, power would go down. You can't literally increase power by increasing 1 minus beta. That is what beta is. Now, if you decrease beta, you would actually decrease power. So you notice how these here are the wrong thing right here. So they're just wrong. You can't literally do this. You would do this by altering your alpha or your sample size, but decreasing alpha would decrease power. Power is the equation 1 minus beta. And check this out. I finally get to eat after this question. Good job, Leo. Grab some food. We've been going for 3 hours reviewing. Yup. And I will say this. We will probably be reviewing the day before the test because maybe even the day of the test. You never know. Maybe Tuesday night. We'll take some breaks right here, be answering emails and getting things graded and prepared. But the 3 things that control power are effect size, sample size, and alpha level. And the only one we really have control over right here in this example is the sample size. If it said increase alpha, that would also be an answer. If it said increase effect size, you don't really control the effect size. So great work. Tiny Brian, lead us home. You got this.
Can I? No, wrong voice.
Can I get some fried rice? I want that. Can't believe it's been so. Oh no! Woo! Let's do this. Tiny Brian, away! Where's my parrot? Give me my bird. Let's do this. Here we go. In 3rd place. Wow, 24. Mystery Pony. Great job. Great job right there. That's awesome. And then we have Epic Hen. Great job. And last but not least, you know it. It's Decisive Goose. Tiny Brian, away! Where do you take me, Burb? Burb. Stop it. No. Okay, wait. Gotta go back here. So I exist in reality. And now, Tiny Brian, away. Oh wait. Tiny Brian's not at the bottom of the screen right now. Tiny Brian. Oh wait, my Burb needs to go with me. 2 seconds. Technical difficulties. Tiny Brian's parrot needs to be... You didn't land me. Tiny Brian, parrot. Do your thing. There. Oop. There we go. Perfect. There we go. Thank you, Tiny Brian parrot. Bye-bye.
Tiny, he's losing his mind. He's going crazy. Great work right there. Tiny Brian, extra tiny these days. So extra great work right there, everyone. Great job. We're going to put all the timestamps in the video. Let's go do that now so we don't forget. Wow, that was a 1 hour and 20-minute Kahoot doing lots of review right here. Exam 3 review extravaganza. So check out the remaining videos on the channel if you haven't. Can I not edit? Exam 3 review extravaganza. There we go. Looking at the screen, editing the timestamps, dropping them in. We've got it right here. The timestamps are now in, but I do want to point you in the following direction. That if you are reviewing right now, check this out. Make sure to know, and good job, good to see you here, Sailor and Caitlin and Millie. We have these reviews right here from part 1, part 3, part 2, and this is kind of part 3 right here. Where we did a lot of review. Can you please link the Kahoot? It's on there, is it not, Leo? Let me drop in the chat right now. I think I can do it. let me do this right here. Let me create a link for you to play. 2 seconds. Is this not capable of doing? Let me send you a link. I think I can make it like a link so you can do it just to say the question. 2 seconds right, I'm logging in. Assign. I think I assign it. Oh, wow. It's can be due by then. Okay. Personalized learning. Create. Okay, wait. And invite. Play Kahoot. So here is... 2 seconds. I think I hit an extra key on that. What chapters is the exam over? The exam goes over the confidence intervals all the way to... And so we'll show that right here. Let me leave a screen. There is a link in the chat right now. You're welcome, Josh. Good luck to everybody. If you're looking for the concepts on the test, you can see right here the topics for exam 3 are located right here. And you'll notice everything right here is the topics for exam 3 found on the link. Thank you, Ava, right there, putting in the chat also. Did I miss anything? The Discord bonus went in as score out of 2 points. Yeah, it's got a prom Alistar. I might need to download it. The Discord went in as a score out of 2 points, but will points be added to our grade as determined or 0? It'll be entered in out of 0.5. I'm trying to figure out how to get that off of Canvas properly. When I'm entering the points, I'll figure it out. But if you feel like your grade wasn't entered properly, please let me know. To host the Kahoot. Oh no. It should be, oh wait, and then game pin. Invite more players. Let me retry this again. Let me try it again. Gotta fix it. Assign question timer randomized. It says it should do it. So points are ready to be put in. If you have your points, you can. So because the bonus grade right now is have like a 70 or something, which I figured would. Oh no. Oh, is it lowering your grade? It shouldn't do that. Let me see. It shouldn't be in a grading. Let me go over to this screen if I'm going to do that. Let me make sure it's in like only its own thing, like unassigned, because I don't want people to see their grade go down. Let me fix this right now because that could be a problem. Let me go to the main screen. Let me make sure this is not in a grading category that is going to do that to your grade. No, it should not do that. It's in its own thing with a 0%. Here, I'll show it. I can show this. Back to the main screen. You're welcome, Leo. You have to do. So it's in its own grading category right here, where it's 0% of your grade. So it shouldn't do anything to grades. It shouldn't do that. It shouldn't lower it because it's in its own grading category with 0. So it should not change it because it's worth 0% of the grade. So that shouldn't impact it at all. Like the Proctorio tester system. Yeah, the way the Canvas does grades, it shouldn't do it. It's worth 0%. So you could just get a 0 on it and it won't lower anything because it's not doing a percent calculation on your grade, whereas where other things are. Did you send? Yep, the link was sent out, and Leo's saying you have to use like 2 things. It's the link Kahoot gave me. Check out the Play Kahoot link up there. Do I still have it in here? Apparently, this is it right here. That's what Kahoot gives me to test it out, but also go through and rewatch and practice doing the problems. That's what Kahoot gives me for self-paced learning. So if we find another way to do it, but that's what Kahoot chose. Any other questions? Heading over here. I'm taking the exam tomorrow. Does my homework need to be done by then? It can be done by Wednesday, Mary. It can be done by Wednesday. And make sure if you have requested to take the exam early, please make sure it has the right time. So Mary, it should have that exam time in there. You should see that the dates show that, like opening, closing tomorrow. And then you do have until Wednesday like all other students. You're welcome, Mary. What time is the exam? I'm taking it on Tuesday. I have it open all day Tuesday, Kendall. If you requested it on Tuesday, I have it open all day Tuesday. Correct. That way it's just easier not to do like Tuesday morning, Tuesday evening. It's just like someone says I can take it Tuesday. Oh yeah, we'll just put it to Tuesday. Just makes it easier. It's because like if you do like time windows for everybody like on a day before, then it's like, okay, someone's like, I can take it Tuesday between 8 and 10. And then you literally have like all these slots on Canvas and it can get more confusing. and that just leads to errors where I have someone in the wrong time slot, which I've done before. I mean, we make errors. And so please, 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 if you're watching this and you're taking it early and you don't see your time scheduled, I think I have everyone up to date as of this morning. So I think I did it on study day. I put in all the times. That's when you saw your time change, probably if you request an early time. And then I did all the times. I keep a regular check on it. But if you requested during the Kahoot, like if you just put in your request, which please make sure you put in your request as soon as possible. But if you just put in your request, I probably haven't done it because I've been doing this. But yeah, that's got it. Any other questions? So mine says 6 through 8:45. That's my time slot. Are you taking it the day of the day of the exam, Madeline? Is that correct? So Madeline, you're taking it Wednesday at the day of. Good to see your Fran. Is that correct, Madeline? You're taking it Wednesday, just regular old time. No, you didn't put in a request, which is fine. Only if you're requesting to take it early, you have to put in a request, and then we get it scheduled for those times. Is that accurate, Madeline? Let me know if it's accurate here. You can email if you like. I did. Yeah. That's exactly right. That's the usual time. That's the time per the registrar. Hence why we put it at that time, because that is the time per UT is our time slot. So we set the time to that. Does that make sense? So unless otherwise requested, it is per the UT time slot of when Stat 2-1 is scheduled. But if someone has a conflict, they have a flight, they have something they have to be at, I'm pretty open to it. I'm not gonna say like, oh, you have a this or that, like your so-and-so's getting married or something. I'm just choosing randomly. You might say, well, that was me. No, but there's a lot of weddings going on right now. So like, if you're getting married, I'm not gonna be like, nope, you can't go to your wedding rehearsal. You got to take the test. I'd be like, okay, cool. You getting married? Cool. Well, okay, you want to take the day before? Okay, we'll do that. But that's you requesting. This has been set by the registrar. We can move it forwards. And the good thing is we're the last exam. We don't generally move the exam backwards. We do move it forwards. If you have a conflict, we do move it forwards. We've always had that kind of policy that we'll move it, because I don't think it's giving an advantage. I mean, I'm not saying like, oh no, you have to take it early, but I think it's not an advantage to take it early. It'd be an advantage to take it like a week later. So we would have to have more documentation. Please let us know if something happens. Like if day of the test, accident, problems, things like that occur, please let us know and we'll work with you. The sooner you let us know, the easier it is to work on it. Well, with that, we'll be back here some more probably. Bye for now, everyone. Bye. I'm going to head out and get something to eat. Great. Enjoy. You're welcome. See you in BAS next year, Hayden. Bye. Bye, everybody.